Hello, hello. It is week 19 of the boost. The lighting and everything's a little bit weird because we are doing this on a Friday night. And I cannot promise that I am not going to partake in a little imbibement, maybe a little bit of alcohol. I did drink some coffee to keep myself awake. We're going from 7 to 11 p.m. tonight, so come on along for the ride. If it is a mess here, I am going to put a plug in for the other stuff as I usually do. We now have three other regular things that we do. We do home lab init, which we did 6 hours of today, where we talked about etcd and how to check this disk speed to see if it's capable of handling the I/O per second and all that stuff. A lot of fun thing. I'm going to say it again. So home lab init is kind of the successor to the boost. So we do things like in Kubernetes and hacking and all that. Speaking of hacking, so Monday and Wednesday we do hacking from 8 to 9:30. And Tuesdays and Thursdays we do home lab init every week from the same time from 8 to 9:30. Some weeks I have to cancel or move things around, which is why we're doing the boost tonight instead of tomorrow, because tomorrow I'm going to be IRL streaming a very amazing art opening at a huge gallery downtown in Charlotte. So stay tuned for that. So just a little bit of information there. We have had, I just want to say hi, wave if you're new. If you're here and you're in the chat and you're new, wave to YouTube. And because it seems like we've already got a few people new, or they're just coming into week 19 because we streamed at a different time. All right, so what are we going to do tonight? And so we are, I think, 4 weeks into the Go programming. And if you want to see exactly, so here are the challenges that this is RWXRob/challenges. You can go there and see them. They are not fleshed out in any way. I haven't moved. I have all of this, the instructions about how to do this kind of stuff, the requirements and thing is written, but it's all buried in an old SKILSTAK repo that I lost when GitHub decided to disqualify me as being an educational institution and take away my organization, which is a long, sad story. I won't tell you right now. The stuff still exists, but anyway, so that's the reason that these are just one-liners. But I generally know what they are, and these mini challenges, as we've talked about before, are designed to just be fun projects, repeatable projects, the kind of thing that you could do as an exercise and keep doing it over and over once you've done it, and then kind of reiterate the basics. So they're also designed to cover everything in basic Go programming. And by basic Go programming, I mean anything that you would generally learn in Python or any other starter language in a beginning programming class or boot camp, up to and minimally including concurrency and things like that. But we haven't even got there yet. So today we finished hello and hi and greet, which were entirely focused on writing utilities and the basics of like just how to write a command line thing that runs in Go, and how to read from the input, standard input, how to output to standard output, standard error, what those things are. We played around with a little bit of language internationalization. In fact, we went down kind of a internationalization or a language support rabbit hole last week, which was fun because I've always wanted to do that a little bit. And we made greet in French, and then we made it in the other languages. And we introduced Unicode a little bit during that. This is the Go Beginner Boost. Yes. Go is in the basic beginner boost. It's the Linux boost, but Go is in the beginner boost, the overall beginner boost. So, and we use things that the terminal and all that, tmux and all that we covered in everything else. So in case you're wondering, I mean, if you know all of that stuff, you could technically start up. I thought about making a separate playlist just for the Go stuff, because technically you could just do the Go boost. And by the way, Go is not going to be the only language we're going to do. We did Bash before to get the basics of like what a variable is and what a loop is and what a function is, and yeah, not that many here, but and then we're going to go after that. We're going to try to finish this before Christmas. I mean, we're going to be pushing. I was thinking we would be finished, well by now, but we're just taking it very slowly. To be fair, I had a negative comment it wasn't really negative, but it was a comment that I deleted from 2 weeks ago. It was like, you could learn all this stuff by just like reading a book and then doing it. I'm like, okay, what book? Because there's no book that covers the stuff that I cover. But you're absolutely right. And I've said that in the first couple of weeks of the boost, is like, This is designed to be really handholdy and stuff, as opposed to telling you what to do and then letting you go do it and then reporting back, which is what we did, the last 2 years of the boost. And that didn't go off very well because people like their hands held when they're first starting. No offense, but people like to, program along with them, which is, until you get your feet under you, this is a good way to do it. That's pair programming essentially, and that's what we're doing. So you're a Java dev, and you just had to go a week back. I'm trying to create an RDMS and go. You're a Java and a Python developer, and you're gonna make your own database. It's to learn Go and inner workings of the DB. Yeah, something like SQL. Okay, so the idea of redoing something that already exists is TJ Holloway-Chuck's primary advice. In fact, only advice. We covered that in either Q&A or Coffee Talk recently. So thank you for the boost. Okay, and so we're going to go through this slowly. And so here's what we're going to try to do tonight. We're going to try to do term colors, which just prints the basic term colors. Hey, Dr. Verm, we're doing a beginner boost tonight in Go. We're doing Go programming. So Dr. Verm is a great streamer who does a lot with Go. Where has set-OPI been all my life? You'd think that they would be mandatorily taught to everybody, right? I'm glad you found it. It could not have happened to a better person. All right, so then we're going to do something called yen, which is which is a fun. I know it's on Friday. We're doing it. People are finally making their way over here, so we're going to get a little bit of interruption. I apologize, but yeah. So we're doing it on. I just got to telling everybody we're doing it on Friday because I have a thing on Saturday, and Saturday's the new normal, right? Let me just show you the calendar really quick. So, just so everybody can see. If you don't know, if all of these changes are like messing you up, just know that you can go to you can do the cal command, and that will take you to a link to the calendar. This is the week view of the calendar, but if you do the month view, you can see the stuff that's on here. Actually, let's do your view. This is my view. It's got my own work stuff on there. Nothing to be afraid of, though. I'm not doxing myself in any way with that. So if you click on, here we go. So here's, wait, what? Don't worry. That's also not doxing. This is me buying stuff from Iraq. I can't wait to tell you about this. I found these. Okay, can I home lab in it, my friends, probably on Sunday. I found this really, really great thing. Look at this. It's $140. It's $140. i5 3.7 gigahertz, 16 gigabytes of DDR RAM, and 256 gigabytes of SSD. These are literally like custom made to be control planes for etcd and Kubernetes. I bought 3 of them. So anyway, I had to share that. It was like really cool. Dude, I'm saying dude. That's what I do. I don't mean it to be misogynistic. Okay, so here we go. So as you can see, normally beginner boosts are on Saturday going forward. Okay. All right, back to where we were. I know, and they're refurbished. So I'm like, for $420, I got 3 independent control planes with really fast I/O for the disk because etcd is bound by disk speed. I know. So we got veterans in here, and I'm kind of like luring them in. Please stop by. You know what? Tomorrow I'm going to go do that other thing. But I tell you what, tomorrow I'm going to be like getting all ready for it because I cannot wait. Anyway, so I'm building this lab, and there's nothing more fun. Okay, why am I so excited? There's nothing more fun than building out your own lab. And by the way, next year's beginner boost, we're going to, if not at the end of this year's beginner boost, I'm going to show you how to install Linux and manage it on hardware, specifically a laptop and or a server. And you can start building your own, 50 machine server rack and work on your, adding on to that as you go. Anyway, so let's go back to the fun stuff. I don't know what Optiplex is. We're going to go figure it out. Dedicated. No, it doesn't. It has a graphics card, but who cares? I'm wasting the graphics cards on my Tridents that are left over, right? Because I don't need them for the control plane at all. And so that's why they're so cheap. It doesn't have a GPU. I mean, yeah, it's the perfect control plane box, like absolutely perfect. Anyway, so, what do I use them for? You use them as Kubernetes control planes. Yeah. and etcd control planes. They're like the brain of Kubernetes. You're going to put your stuff on. Stay tuned if you want to watch Home Lab. We're going to go through all that stuff. Okay, I'm sorry to diverge you, but I don't think it's bad to help you understand what comes next and where we're going. So all that stuff, Kubernetes and Docker and everything that etcd, everything I just talked about, written in Go. Okay, so it's really important that you learn how to read Go, because the error messages in the logs are in Go, and they tell you the line in the .go file that the error was reported. So if you don't know how to read Go in cloud native world, you're lost. All right. So lab low available budget. Nice. I love that. That's a great joke. So anyway, back to what we were doing. So Nyan is a tribute to the memes. This is a long-standing tradition to do memes. So let's get on with it. We do memes in our coding, so you'll remember it, so you can associate a principle with the name of the thing that we did. All right, so yeah, I can go ahead and close this out. We're gonna do term colors first. All right, so and another thing we get to do again is we get to start a project. So this is a time for you to get paid for your unused GPU idle. No, I don't want to. Oh, I'm going to use the GPU. That's why I didn't put them on my other machines. The reason I didn't turn my Tecton machine, my Tridents, is because they have fast enough disks to do cool things with FFS, and they have terabyte drives, spindle drives on them. So I'm going to make some slow mounted storage, which we're going to do that later. Okay, so let's make a Go program. So here's an opportunity for you to review. How do you start a Go project? What's the first thing you do? I ask you this every time, but I'm going to ask you again. What do you do to start a Go project? Okay, so if you're doing this with me, and I encourage you to do that, right? You should have like a week 19, or you should have a GitHub repo or something like that, someplace you're saving it. This is all happening in RDBX Boost weeks, and I'm putting it in 19. And we talked about how you can have multiple projects in a single repo, and it's fine. So how do you do it? How do I want to make a project. I want the command to be called termcolors, and I don't know how to start. Tell me what to do. Well, I don't do no go mod init right now, do I? I do it eventually, but not right now, right? What do I need first? I have this empty directory. I want to make a project in here. What do I need? So this is a little bit of a review. I'm sorry to be annoying, but I'm going to pause a little bit for you to think about this. So before I just go giving it to you. So in order to have anything, you need a new directory. Yeah. So how do you do that? How do you make, I'm deliberately helping you drill yourself. Hopefully you'll do this, right? I just don't want to do it for you. Touch may not go inside a command folder. Well, yeah. Yep. Yes, that's definitely something to do. But what did we do last week? Last week we had a huge conversation about whether you should have a command or a library package. And what did we conclude and why? Do you remember? If you didn't catch that, make sure you go back and look. Right? So we concluded that in Go, every language is different, but in Go specifically, for Go, it's almost always better to make a package library, a library package. And what's the difference between a library package and a command package? These are things you should know by now. We've been doing this for 4 weeks, right? We talked about it every time. I'm going to talk about it again. All right. So I'm just going to give you the answers. So we're going to make a directory called, what do we say? What do we call it? Termcolors, right? And we'll cd into that directory. And we have nothing in here. Okay. So the difference between a library package and a command package, or a main package, is that it either has package main in it as this main thing, or it has some other name. And so since we want this to be a library package, let's follow the convention of naming the library termcolors.go and changing the, if you don't want to do that, you can actually just do this. And we talked about that just actually makes a file. And we're going to actually call it package. Doggy is seeing, there's lots of activity because it's Friday night outside. So we're going to say package termcolors, right? And now we just have, that's it. Okay, we have a file, we have a program, right? and we have a package, right? So let's put the bulk of our business logic, our main stuff into a function. So what is the function going to do? Well, the term colors program is all it's going to do is print out all of the different term colors. That's all what it's going to do. It's not going to be any fancier than that, but we're also, not only is it going to print it, but our other programs will be able to import it. All right. So that's the point. And if you don't want it to be term colors, you could just say, why don't we change it? Why don't we change it to colors instead of term colors? Should we say term? Term colors is kind of nice. Let's keep it as term colors. Okay. So let's put a constant in here. So I'm going to give you this one because you've never seen it before. So does anybody happen to know how to print colors in the terminal? Right? You can do all kinds of things like that. Yes. And I want you to kind of get creative with this. All right. So the first requirement is this: create a program that prints something in every color, in every one of the main terminal colors. Okay. Everything else beyond that is extra. Okay. So we're going to say term colors, working on term colors. Okay. Okay, we'll say including a term colors reusable library. Okay, now there are tons of these that have been made already, but we're going to do it so that you can get a sense of it, right? Requirements. Okay. And we also have to have covered. All right. So actually let's do the requirements in a different one. Oops. Okay, let's go back to, we're going to go back into term colors. Whoops. Weeks 19, term colors. I'm going to label these things. Let me tell you, do you guys remember how to do that? So control, it's like leader, comma, term colors. I'm renaming my terminal so I know what I did. And we'll make this one the readme. I'm getting my IDE kind of set up. And yes, that's what we're going to do. That's exactly what we're going to do. So, but we need to do that in Go. So we're learning about printf. We're learning about ASCII terminal colors and all of that stuff. And so let's change this one to be challenges. Yeah, CD challenges. And so let's make one term colors. Term colors. Okay, so term colors. So create a, let's just start. So create a library that contains constants for the starting for each of the standard ANSI terminal escape colors. All right. That's the main thing. That's the first task. Okay. So if you know how to do this, or you want to go run ahead and do it yourself, go figure it out. But I'm going to do it the slow way, and I'm going to talk about it. Okay. We have to talk. We have to do a lot of things here, right? We have to talk about what ANSI terminal escapes are. We have to talk about the ASCII values. We have to talk about color in general and whether terminals discuss it and all that. And we're going to do all of that right now. All right. So this is actually, I already have a program that does this. Okay. You can do this program in Bash, by the way, right? And I'm going to cheat and give you the answer in Bash. So here's the Bash program. The Bash program, that this is actually POSIX shell, but it tests to see if it's got a terminal or not. Test-T1 tells you whether you're a terminal, right? And if you are a terminal, if you are an interactive terminal, it sets the things. If you're not an interactive terminal, it does not. It leaves them blank. Okay. And we should probably add that as a requirement. Let's do that. That would be really great. So, oops. No, which one am I in? Oh, whoopsie. Okay. So, we'll call it boost, bonus. Detect if the terminal is interactive and replace the all escapes with empty strings instead, so that redirecting output does not contain the escape sequences. So there's a bonus for us. Okay. And let's go back here. So in Bash, you can do it pretty easily just by printing /e. Okay, so I'll just jump right in. You'll remember back in the day, and I'll try to find a visual aid for you, TTY machines. We talked about terminals and what they are and how they evolved, right? And so a TTY, which is what everybody gets assigned when they have a new terminal, actually comes from the teletype machine. And we've talked about this at least 3 times now on this boost, but I want to remind you of this. So when there's actually a video of Dennis Ritchie programming his very first C, and he's looking at this. He's looking at a teletype machine instead of a screen. He's typing out things and he's watching what happens on the paper. And it's just like an unlimited amount of paper that he just keeps printing. There is no screen. There's just paper. And it wasn't until sometime later, after the invention of the Unix operating system, frankly, that they actually had interactive screens. And you can go see this. This is just a recap of what we talked about before. But it's important that you understand this, because everything about how terminals operate is based still to this day on sending command characters to the screen, to a device, which goes into a device inside of the kernel of the computer, and then taking those things and spitting those out into, the thing that's going to render it. And up till, screens were invented, that meant sending a special, 1 and 0 combination, a byte, string, or a character to one of these things to tell it what to do. And we talked about that extensively last week and the week before when we were talking about something called carriage returns and line feeds. And those were all backslash, you'll remember. They're /r, /n. So if you want to force the screen to start a new line, you have to send a /n. And it used to be that, in fact, there's still some discrepancy about sending a carriage return, right? Because a line or a line feed, a line feed is different than a carriage return. So all of these commands were codified in something called the ANSI terminal escape sequences, which was, and initially they only had room because of the number of bits and bytes, which we'll get to do a certain number. So that's when we started to see the ASCII table, right? And the ASCII table initially was enough because it covered, you can go search for it yourself, but the ASCII table initially was fine because they are totally related. Yeah. They're all special sequences. Well, the /e specifically is to say, hey, get ready, we have another thing coming, right? That's actually to escape the thing, but they're gonna get related. It's actually an escape is what it is. Okay. So if we go, so here's the table, and you can find this table anywhere, but as you can see, this table, for the most part, once you get over here, it looks like stuff that you would see on a typewriter, right? And so the original set of characters that could be used was equivalent to what you would have on a typewriter. But because they had to make these things into 1s and 0s, because everything on the computer is a 1 or a 0, and specifically 7 of them to combine, because they left off a byte. A byte is 8 1s and 0s, and a bit is just a 1 or a 0, and the ASCII thing used up only 7 because they saved 1 or 0 for positive or negative. So that's the very, very basics of how computers work. And we're going to write a binary counter eventually that talks about all of that. But and Dennis Lastmiles has done a lot of good stuff about showing, because he works in the kernel a lot and on a really low level. And so you have to understand, bitwise mathematics and binary and base 2 for mathematics and stuff like that. So, but all you need to do for today is know that there were 127 possible values, and these things are sent to the terminal, right? So every time you press a keystroke on your keyboard, if you press the number 4, it actually sends a decimal 52, but it sends it in binary to your terminal emulator. Now, this is something else that's going to kind of introduce us to this. So, and notice I said emulator, right? So, ANSI escapes as related to ASCII table. So, terminal emulation, right? So, when you use, so we downloaded, Microsoft Terminal Preview in this case, or iTerm2, or whatever you're using, GNOME Term if you're on Linux, and or Alacrity is another one. All of them are terminal emulators. They're not terminals. All right. You want to know? You want to see an actual terminal? All right. So an actual terminal would have been a TTY, a teletype machine. That is the original terminal. And I mean, very quickly in the 70s, they started using the word terminal to refer to something with a screen. But strictly speaking, the original terminal was a teletype terminal. It wasn't a screen. All right. So, and that's why we talk about terminal emulation, right? And by the way, when they started to invent these things instead of teletypes, they started to invent lots of terminal emulators that there were lots of different physical type of terminals, and then they were different, right? They use different methods of communicating, and in fact, I don't even think a lot of this character return line feed stuff was even settled for a very long time. I'd be interested to look in the history of that. But all you need to know is that the thing that you installed that you type into is a terminal emulator, and everybody pretty much agrees on a couple types of terminal emulators today. And you don't have to go deep into this, but you just need to understand this, right? And so there's one of these terminals actually won. All right. So after the teletype, there was a bunch of fighting sort of about what teletype machine, what terminal standard would win. And the clear winner was VT100. All right. So here's an actual VT100 terminal. But there was a time when people would have had, like passionate debates about what terminal should be the one that the rest of the world used forever, and this one won. And IBM had one. There was a number of other ones. In fact, if you want a fun side quest, you can go install RetroTerm, which Windows Preview has actually sort of built in its own way. But if you want to, you can install cool retro terminal if you want to have a lot of fun. And I'll put that installing cool retro terminal for fun. In fact, let's do that. I like keeping it fun. So let's do it. Let's go ahead and install it. I haven't installed it in a while. I don't think you can apt install it anymore, but you see all these different terminals you can get. And I used to when I first started streaming, this is what I streamed from. And I had a tmux window so that you could see the two. In fact, you can go to this day. I have a video on this. I think it's still up. Yeah, if you go up in my video list and you search, oh god, you're gonna see all my ugly videos. But if you go to my channel and you search for retro term, there it is. So the cool retro terminal. So this goes into This is back when I was very first streaming, and I thought I had to be sneaky and funny. No, but and I go through completely how to set it up. This is when I very first streamed. This is what I did. I just made it look really, cool, and got tried to sneak people into coding in the terminal, and I this actually talks about how I had. See, I have this cool terminal, and then I also had this other terminal was the terminal I was looking at. So I was looking at this terminal, and you guys were looking at the other one. I've given up on attracting people through tricks and fancy terminals and stuff like that. I just am here. I don't do that anymore. but yeah, if you want to go look at that, let's just skip that. But if you want to pause the video, if you're on YouTube or whatever, and you want to go set up your own retro term, you can do that. I do kind of want to install it, so I think it's Friday night. Maybe let's try it. So, but this goes through everything about how to put it in there. We were showing War Games because War Games was the terminal. It does show you all the different ones that you can have, and yeah. So it's just it's an app image. Oh yeah, my eyes were dead forever. I mean, people complimenting me on my terminal right now. This terminal, as you're looking at right now, it might be boring, but it's designed for one purpose: to keep your eyes watching it for long periods of time, even if you're on a phone. And that's why I've chosen the font sizes and everything that I have. This is not normally something. I mean, my Mac, I've got stuff much smaller, so I can fit more on the screen. But if you want to understand how to do it and install it, you can go ahead and do that. In fact, I think we're gonna skip it. I maybe during the break. Maybe we'll do that during the break. But it is really fun. You can change the bevel on it, and I mean, you can get really nuts with it. By the way, I mean, look at that one. You can get so crazy with it. And I used to, have the fish, and it was all about the terminal. This was, how we were going to do it. And I was just, it worked actually. People got really, really into it. But you'd be surprised how many fish you can hook. Fish being, Twitch viewers, doing this crap. And it worked. It worked. A lot of people came, but I prefer people come here for reasons besides that necessarily these days. So I don't play that game. I just kind of stay focused and do stuff, which is much more boring. But I mean, I had a lot of fun doing that. I don't know. Part of me wants to go back to doing that because it was really fun. It was really fun. It's still fun, but I don't need a cool retro terminal to have fun. I can do other things. So anyway, there you can go. You can go install your own. You can have fun with it. It came from Rob Slick's day for his brain. I mean, look what I am now. I went from being like this, like silly, edgy. Now my dog's random bone is in here, and I have this like horrible lighting, and but ugly like room. Things have changed. All right, back to work. Here we go. So, because I'm doing stuff now. Anyway. Most I do is I turn my lights off. Should I go turn my lights off like I usually do at night? Right now, I usually turn the lights off because it's just too bright, but whatever. Anyway, so here are those escape sequences. And you can see in Bash, it's kind of a pain, right? But we put these escape sequences inside of a variable, and then we printed them out. So back to our ASCII table. Let's go back to that. Where was it? Let's go back to the ASCII table. So here's the terminal that won. VT100 won. And thank God it did, because there's still, to this day, there's still a thing called termcap, which, you'll hear about. I'm just going to say the word so you'll recognize the word if you hear it, right? And and termcap. So it used to be, there was a fight, termcap and terminfo. There's actually a Riley book on that. Wow. There was nobody really agreed on how terminals should behave and what the escape sequences should be and all of that. So they created things called termcap. In fact, if you're old enough, you'll remember at one point you used to have to, if you push the delete key, it wouldn't delete things. It would make a thing, it would print it to the screen, and you would have to change your stty. You'd have to change your terminal cap. And that's, by the way, let's do this. So, understanding term cap and stty, and you would have to do these things, right? So you don't have to do them now, thank God. And you'll see stty is still a thing. But most of the stty defaults are all fine. Nobody even has to think about this today. In fact, you can echo term, and it will tell you what kind of terminal you are. Now, okay, before you freak out, you're like, I thought you just said all this stuff about VT100. Okay, so VT100 is the most simple basics for terminal emulation. Everything supports at least VT100, right? But there were a lot of other terminals, and a lot of them built on the capabilities of that terminal, right? So I don't believe actually that VT100 actually supported color at all. In fact, let's find out. Did VT100 support color terminal output? I don't think so. This is why it was always all green or all white. You might have to go back a while. VT100 is the video terminal introduced in August 1978 by DEC. It was the first terminal to support ANSI escape codes for cursor, color case, and other tasks. So there you go. And added a number of extended code for special features like controlling status lights on the keyboard. Ooh, I wish we had control of that still. Guess we don't have that anymore. What else do we got? So ANSI for... And added a number of extended codes for special features like controlling the status light. This led to a rapid uptake of the ANSI standard, which then became the de facto standard for hardware video terminals, and that's what we're talking about tonight. The VT100 series, especially the VT102, was extremely successful in the market and made DEC the leading terminal vendor at the time. The VT100 series was replaced by the VT200 starting in 1983, which proved equally successfully. Ultimately, 6 million terminals in the VT series were sold based largely on... Can you imagine having to buy a terminal? By the way, when you used to connect a terminal like this, you would connect it with a phone line, and it would send... You can still do this, actually. I just did my OpenSense router, and the device that I came with, I think I still have it here. Where is... let me see if I can find it. So it came with... No, I don't have it. Okay. I don't have it available right now. But it actually came with a serial cable. And so if you don't know what a serial cable is, it's like what we use USB for now. But it used to be that you plug those things in, and they look like they were phone lines, but they weren't. And they were actually serial cable, and you plug it right in. And place them with the custom scripts. Yes. Did you replace them all? Kermit serial coding for the terminal. Hell yeah. Yeah. Kermit was a program for doing terminal like serial communication. And, I'm just giving you the overview of this stuff so that when you encounter it in the wild, then you might. So there's still dumb terminals that just speak basic terminal. That's it. And some of them are literally tied to phone lines that are connected via modem all the way back to some central server. And there's still a ton of these out there. In fact, for a long time, point of sale stuff like at Lowe's or, Home Goods or someplace like that, they were running VT100 terminals. Do you remember the old ones? It's hard to find them now, but every once in a while you'll see somebody like tapping out on some green screen, and they're using terminals that are usually phoning home to some Unix system or mainframe. So that's still a thing. Current precursor to the AT commands for set modems. Yes. And so DEC's first was the VT105. Anyway, so as you can see, there's the IBM 3270, which is one of, if you do IBM RetroTerm, actually, let's go. Where is our? We have a link to that. Let me show you. That's actually here. So here's you have the default Amber, which is like the DEC, and there are a number of other ones. So this is Mac GCC. Let's see. No, that's not. This is, which one is this? One of them is, anyway, there's one that is designed to look like a Mac, like an IBM 3270. I believe it's this one. It's like very clean lines and everything. Anyway, if you're a terminal junkie like me, this kind of stuff is kind of fun, especially if you're old. And there's a lot of people out there that still appreciate it, even if, they just barely learned about it. So there are lots of terminals that came out, and one of the Swordfish standards is Xterm. So, and I believe it's fair to say that Xterm was the first terminal. Xterm color. And I believe Xterm was the first terminal extension of the standard to support color. So Xterm 256 color. Years ago, so fun. Yeah, you did a Kermit with a basic chat. Nice. Unix has been around since the 1970s, so you might think color support would be easy, but terminal emulation is complex and it leads to user connected to systems with different capabilities. This complex capability means there's a lot of pieces that can cause difficulty. So, so color wasn't even supported until I think Xterm was the first. And then we had very recently, relatively, like within the last 5, 6, 7 years, we started to get millions of colors of support. So we're gonna dive deeply into all of that tonight while we're writing our code. But I had to give you this kind of background on it, right? And now these days, you get watch your eyes, flash alert here. So you can type sunrise, and you get this kind of grainy color. And we can actually write this program, but this, as you can see, this is kind of grainy. You see how this because this is being forced to use the wrong terminal type, and it's the wrong terminal color set. But if you can actually make it so that you get nice, smooth millions of colors, and everything goes together very nicely. But my tmux is actually messed up right now. Still, I fixed it during the boost where we did tmux, and then I left it broke, unfortunately. So it's still just doing. Not 256 instead of millions of colors. So terminals now have millions of colors of support, and that's a thing. So there's a couple of commands here that I'm going to throw out to you that you can go read about, understanding termcap, tput, and stty. So I'm not going to go deeply into it, but these commands are pretty much on anything, any Linux or Unix system has these things. And, PowerShell supports color too now. So what ended up happening is that all of the terminal emulators, and in 2019, Windows finally got in line with the Windows Terminal Preview. And you can go read, watch the video about it. There's like an hour-long video about when Windows finally created a terminal that supports color properly and all of the escapes that go with it. Up until that point, there was nothing. There was nothing on Windows, period, that did it. You had to get an extra terminal, and you had to, use that instead. But that was the first time that Windows created their own terminal emulator that was proper. Before that, you had to put other stuff on that. No, we haven't moved yet. So we're in the middle of a beginner boosting. So that's kind of a thing. If you want to see your terminal variable, you want to term. Spoiler alert, if you're doing Over-the-Wire Bandit, it's a hacker game, you can actually hack one of the levels by changing your terminal value, because for some stupid reason, it actually executes the content of the term value. The term environment variable, which we talked about in Bash, what environment variables are, actually propagates to an SSH target. So let me show you this. So if I SSH into mini1, and I echo term, it has the same terminal value. Isn't that cool? It's like it's one of the very, very few environment variables that follows SSH across a remote connection. And you can actually use that to hack one of the levels on Hack the Box. So I'll give you that one. Anyway, I'm not Hack the Box, on Over-the-Wire Bandit. The reason I needed to get you that kind of verbose overview is so that you understand what these things are when people are talking about them, not so much so that you can have a comprehensive knowledge of it all. So next time, so it's like a level 1 understanding, right? Versus like 1 to 5, right? 5 is who wrote the book on it. And you know what the words are, right? So when you come across a Stack Overflow that says, oh, you need to tput no echo to turn off or stty no echo or whatever, to turn off your password, you'll know what's going on. Okay. So termcap was a standards attempt to get all of the different terminals to play nice with each other. And so everybody agreed, okay, we're gonna create a termcap for our DAC VT100 and for all of these things. Termcap is virtually useless today. And I mean, there are some uses still. So I still have, a, if you go see these environment variables, a lot of people don't know this, but you can actually add color to your terminal to any ancient thing that used to recognize termcap. and that includes less. So people have asked me, well, how did you get colored man pages? And the way I have done colored man pages is something that will work on any Unix system whatsoever. This isn't some extra magic like they've done, and some people come up with different tools that replace less and things like that. No, this actually uses this by using these ancient terminal, and I covered this when I went through my bash RC, and setting these values to escape sequences. And unfortunately, that really messes up my env output, because now my env output's got color in it, right? Because the actual value has to be the color escape. That's an acceptable side effect, I suppose, but I don't like it. But that allows you to do man ls, and you can get colors, and you got the blue and everything. Okay, so again, termcap was a thing to unify the division among all of the terminals at the time, and the only vestige of it left that you care about is that the standard VT100 X probably X term 256 color is pretty much the standard now everywhere, and that you have these commands called tput and stty, which to this day are to help with these kinds of things, and you can still use them to do terminal things that you might want to do instead of sending directly a character to the terminal, which brings us to the next part, which is how do you make these things work? Okay, so tput, sets all of this stuff, string, integer, writes the decimal to the standard output, Boolean, more capable. You can read about it. You can man stty will change different things. But tonight what we're going to do is we are going to leverage the advantage of just printing any of these special, ANSI escape characters to the screen. That's all you have to do. And they're considered white space. So let's go back to our ANSI terminal again. So if we go back to our termcap, let's go back to the ANSI. Where's our ASCII stuff? Did I throw it out? Where's my ASCII? I had a great ASCII and I threw it out. I feel bad. All right, here we go. So we gotta have this thing up, because I gotta show you these different values. And all right, so here we go. So here's I'm sorry for the brightness, but as you can see, all of these things are up to like, what is it, 31? Yeah, that's one way to do it. But yeah, in printf it does the escapes automatically. Yes, there are lots of fun ways to do it. Yep. And I mean, if you're gonna do that kind of thing, right? So we already covered that. You can go look at the that command, the term colors. But we're gonna do it in Go. So here we have all of these extra things. So here's the actual escape sequence, right? It's 033, and we have the other ones that are important. Actually, you can force it to backspace. You can get really creative, because you can clear out the existing line. We'll get to that later. But more importantly, we have like character return line feed, form feed, and a bunch of other things. But this is the real key one right here, escape. So you need to send an escape sequence, an actual, as if you typed the escape character. Has all the ASCII. She really does. Yeah, and so this is all this stuff you can send. I always thought it was weird that the numbers don't align with the binary equivalent or decimal equivalents, but whatever. So let's talk about this for a second. So first of all, we need to be able to print things, right? So let's jump right on to that. I mean, if you can do this with okay, first, how do we do this from bash? All right, so, and let's cover that. So somebody mentioned it already, so let's go ahead and go for it. So if I echo, so here's the sequence, and I know I'm all over the place, but there's one other thing I want to show you. So the thing I'm going to show you right now is so large and complicated that it can be overwhelming. So, because there's a lot of them, but we're just going to start with the easy ones. So if you search for ANSI terminal escape sequences or whatever, it'll show them to you, and you can see them Uh, and you know, it has the whole thing about the terminals. Okay, so here we go, and that has the different control sequences for the different ones, and it's just, yeah, we're not gonna get too crazy here. So these are, nope, that's not the right one. All right, so here are the color ones, right? And it tells you right here, examples to get black letters on a white background, do escape left bracket, all right? And then there is a number with a optional number with a semicolon, and then another number, and then M. Okay, so the thing to keep in mind is you have the escape, the actual escape sequence. That's the 2B or whatever. And then you have a left bracket character, and then you have the color code. And so you have the foreground and the background here, right? And then you have an M, right? So it says here to use red, use escape 31M. So if you don't provide a foreground color, it assumes the default, right? But if you wanted to have mixed colors, you could do that, right? So that's what's going on here. And so as you can see, and they go in order. You have RGB, you have black, red, green, blue, yellow, magenta, cyan, and white. And those are the only colors that are supported universally on literally any machine that uses color. And there's actually a strong argument to only set those things. And I'm going to show you why. People are like, well, don't we have millions of colors now and thousands of colors? Yes, but you really don't want it. And unless you're fully controlling the terminal experience for the user, you probably don't want it. And I'm going to tell you why. Well, the hint is that it has to do with themes, right? So if you change a theme, themes will change the colors for this. So let's go to the terminal. Let's go to my terminal preferences really quick. And if I can do that. Oh boy, wrong thing. Here we go. So I'm on my Windows Terminal Preview. I'm going to go down to settings, right? And you can find the similar things in your iTerm2 or whatever you're using. But if you go in color schemes, you can see the different color schemes, and you can see how, what am I using right now? Anyway, I don't want to mess them up right now, and you can like try them out, but you'll notice that there's 1, 2, 3, 4, 5, 6, 7, 8, right? And this color right here corresponds to the, those colors we were just looking at, those color sequences, which I think are 31 through 38 or something. And the other one down here is the highlighted or the light variation of that color. And so by setting those colors, anytime you change a terminal theme, everything that you do will work. If you explicitly define a color using the millions or hundreds of colors, that will always be that exact color, no matter what the terminal. All right. So sometimes you might want that. Sometimes you want very specific control over how the colors appear on the terminal. And other times you just want to change the theme of the terminal. And that's what we're doing. All right. So, and why is this important? So let's actually go back to one of the reasons you care. So people like to comment on my terminal out and my colors on my terminal, my bash RC, right? They're like, oh, that's a fun prompt. How did you do that? Right? Well, I didn't use anything like oh my Z shell or anything. This is all in my bash RC. And you can go to my prompt, and I think I have in here smart prompt, right? And I have this bash code, which you will understand more now that you've seen it. And I can set up the colors and the different things. And so this is my, if I'm root, make my prompt a hashtag. If I'm not, make it whatever. And then down here, we're getting our Git branches and grabbing stuff off of them. And so you can actually have fun with this once we do the little 9cat thing in bash or Go. You probably want to know how to do the equivalent in bash. That's why I'm showing you first. And then you can like print it out. And so this actually, I put the escape sequence for green in $G. I put the escape sequence for bold or in $B, and then this is like manufacturing the prompt and then setting it, assigning it to PS1, and then assigning prompt command to PS1. Now this calls the PS1 command, every time. Prompt command actually causes the prompt command runs every time you hit enter and every time you get a new prompt. And so it runs that little function that I wrote there and writes out that output. And that's what you see on my prompt. Now, there's a million things you can get wrong here. I mean, like if you don't calculate for how many things are being printed out, you can end up having it wrap wrong and do all kinds of problems. And I'll tell you, I mean, I didn't want to get into this yet, but that's what this extra bracket stuff is about. Okay, so I'll just give that to you right now. When you're outputting a prompt, because why? Because an escape sequence counts as output, right? So when your prompt is calculating how many lines over before it wraps, when you print an escape sequence out, it counts it as one or more bytes, right? And it's off. It gets off. And so in order to avoid that, you have to print these special square brackets around the escape sequence that says, don't count this against my number. And if you get it wrong, if you get it wrong, it will print it out the colors and everything, but your wrapping will be totally off. And you'll be like, why is this? And your stuff won't sync up because escape sequences do not advance the terminal output at all. But for the sake of the PS prompt, apparently, the calculation is still included, and so you have to put those in there. So I'm just going to put overview of how to create your own PS1 prompt, right? So I actually encourage you to do this because next time somebody asks you, oh my God, your prompt is so awesome. How did you do that? What tool are you using? As I wrote this myself. Because you can control, it's all very easy to control. You can actually make your own that run anything from your bash RC. And those things can call out to other programs if you don't mind the hit every time you hit enter on a prompt. I mean, you can do some really amazing things. You can have it print like a random, you don't need a plugin architecture for your plugin, for your PS thing. You just write your own. To my scripts, but I like the bashisms too much. Yeah, me too. So I'm a big bash fan. I code everything in bash first. And then if there's a requirement for it to be POSIX compliant, I'll do that. I default to bash now. I changed that a couple of years back because bash is so prevalent on everything. So anyway, and Z shell is certainly not a reason. Bash is so powerful that to throw away the bashisms because you might need POSIX compliance is foolish to me. At now, right? So I don't do that. Anyway, so let's figure out how to do this. So echo, right? So you might think, and we're going to do it wrong first. Okay, so echo what? Well, okay, so we have this escape sequence. So how do you even print an escape sequence, right? How do you even do it? Well, the first thing, yeah, no. So no, I no, yeah. So we know we need to print an escape, but how do you print an escape? Let's see, I'm going to type an escape. What happens, right? If I type an escape, what happens? Nothing, right? So I have to make an escape, right? So there's a lot of ways to make an escape in both Bash and Go. And we're going to talk about the different ways to send a specific number, right? So the easiest way is -E if you have support for that. And that means escape, right? And then you do like, what was the one? 21? Was it 31? Let's just do 31M, right? So let's just print that. You're like, okay, oh, that didn't do it, right? So the problem is that echo by itself does not see escapes, and they're not POSIX compliant, which is probably where that come from. But to make it see the escapes, you do dash. Let's do something called, say, red here, space red, so we don't confuse you. And now you see it's red, right? And then and my colors went back to normal, right? In this case, no, we don't need two of them. So that says go ahead and do it. Now, the printf statement automatically recognizes escapes and always has, and I believe it's on POSIX as well. So you'll also notice that printf does not put a line return, and that's really important. In fact, from Bash, you should be doing all of this kind of thing from printf. Now, you may notice that let's actually get a terminal that does not have a pretty prompt. See how the color of my prompt is actually fixing a big problem that you're probably going to have, and I'm going to help you see this. So let's like go into my Mini 2, which hasn't been set up at all. It's got this. Well, no, it has a prompt, so that's not going to work. Let's go into Docker run -it-rm. Let's go into I don't know. Let's just in Ubuntu. Let's just go into an Ubuntu box really quick. And I think the default prompt, what I'm trying to show you is how it bleeds. So like if I do the same thing, I'm on a root Ubuntu box. So if I do print, hey, so let's do it again. So let me see if I can remember. So it's print. I need set -ovi. Okay, so we're gonna do print f \e, and then what? 31, let's say. Oh, left bracket 31 m, right? And then space, and then the word red, right? All right, so that makes it red. Uh-oh. What? What the hell? Why is everything red? Okay, so that's because these ANSI escape sequences are stateful. What they do is they change the current state of everything that gets printed from the terminal then on. So they kind of inline, which if you can imagine it being like if it were getting sent out to a printer tape, it'd be like, okay, you say, okay, now change the color to red, and it would go, okay, and it would switch the inkwell to red or whatever, and then it would print all red, and then it would get a thing that says, okay, stop that, and it would go, okay, and it would turn off the red ink, and then so that's what they are. They're stateful switches for the color that's being printed, and there's things for everything, not just color, right? There's things for bold and clear and invisible and all kinds of stuff. But the moral of the story is, in order to get it to go back to normal, you need to send a clear. So we're going to send a printf \e/ and I think clear is 0m if I remember right. And yeah, so that sets us back, and a 0m resets the terminal. It resets the terminal colors. And there are other sequences, just to give you a really good one really fast. If people start arguing with you about using Control L to clear your screen because they don't know about set-ovi because they never learned, and you just go, well, why would I run a program to clear my screen when I can just send a single ANSI escape sequence, which is 1,000 times faster? You can do that. So you could actually go. There's a sequence here. I'm going to go find it for you. Here we go. So let's go find the one for clear the screen. So this is the first one that you may not know about. So the very first one you know about is reset. So that's 0m, right? And then the next one is, and it can get very addicting. You'll start looking at all of these. If you've ever seen really elaborate like terminal command line animation where things are spinning or the line is getting redrawn or the progress meter is staying on the same line, this is what they're doing. They're just sending these sequences and they're modifying the current line, and they're sometimes even repositioning in the line after they clear the line, and then they'll reposition and they'll write over the top of something else. You can do some really crazy, amazing animations with this. It's really fun. And I mean, it's not very useful, but it's super fun. So I'm trying to find the one for clear. Reset to initial state, escape C, triggers a full reset of the terminal to its original state. Save the cursor, restore the cursor. Next to emojis. Yeah, you can do emojis. Yeah, most of the terminals these days support them, Unicode. So here we go. So there's the one. So look at this one, 2J, capital J. So let's try that one. Let's see what happens in our little terminal here. So let's do printf \E left bracket 2J, and there's no M. There's no M. M is just for color, right? So it's 2 capital J. Oh, look at that. Did you see that? It cleared the whole screen, but it didn't reposition my cursor or anything, right? So you might want to add something to it, which, so this makes the text green. There's another one that sends you to the top of the screen, and I'm actually going to give it to you. So I have a command called C, my alias C to clear my screen, my alias C. You see how fast that was? Just does a printf, and it prints an E2J and an EH. And what does the H do? The H sends it to the top of the screen. It sends it to the top of the terminal. If I don't do that, we just saw it, right? If I don't do that, it clears the screen, but it doesn't move the cursor at all. So, and you can get like really precise about where you position your cursor. And all of the stuff that is going directly to the terminal. So I told you about tput and stty, and a lot of people you'll read a lot of like Stack Exchange answers that say, oh, use tput blah, blah, blah to like set a color or something. But why would you run an entire executable just to change the color state of your terminal when you know now that you can just printf it using any language and avoid the extra binary or extra execution? It's absolutely stupid. And, you know, I read it all the time. I read people, how do I print color? Oh, tput whatever, right? And there was a time, my friends, there was a time when tput was the right answer. Why? Because there were so many different types of terminals, but every terminal on planet Earth, I swear to God now, that's in mainstream reuse supports the same escape sequences. So tput is largely irrelevant. You still need it for things like this. Probably the most important thing about tput is tput rows. Tput rows and, tput, is it calls? Tput calls and tput lines. There is no other way that I know of to calculate the number of columns and lines of your terminal. That is the only way I have ever found in like 20 years, 25 years. So, and it's universal. So you can use that if you want to do fancy things with your prompt, which I do. I don't know if you noticed, but like when I don't have enough room, my prompt goes to a single line, and otherwise it's conditionally it's on a double line. Or if the prompt is too long, like it is now, it'll make it into a double line. And if it's short enough, it'll crunch it and put it into a single line. You can think of a way to calculate that. That'd be cool. Yeah. Yeah. Must be go to high. I think it is. Yeah. Yeah. And it's a real rabbit hole. So, you know, tput lines and tput calls. So I put that in there for you. Anyway, so I mean that's really the only thing. And the only thing that I really use stty for now is to turn off echo. So let's just cover that right now. Dash no echo. So so like if you want to do something where someone's going to type a password in, this is exactly what everything does. ASCII characters for navigation. I don't know. That would be interesting to find out. So stty dash no echo, right? Oops. I think it's minus echo. Yeah, that's it. So now I'm typing. I'm typing, but you can't see it, right? And I do stty echo, and it comes back, right? And if you've ever used an interactive program that gets hung in the middle that does that, that's how you turn your echo back on. And that's something that it took me years to learn. And stty echo, right? So if you want to write, you know, password prompting and things like that, that's the safest way to do that. And you can have some fun with that. There's all kinds of things you can do there. So, but that's really the only thing I've ever, it used to be we had to do stty set the backspace for delete so that it would delete a character, but you haven't had to do that in 10 years, 15 years. Specific column value, for example, print a long string and use octet to just print the first column and then write for all loop to get a character of the output. No, I would never do that. That's ridiculously inefficient, especially for something that has to run a lot. Yeah, I would never do that. Have you looked at how big awk is versus tput? No way. No way. I would never do that. You can do that. Have fun. All right. So, okay. I hate awk, to tell you the truth. I only use awk for splitting columns when I'm too lazy. It's the only thing I use it for. Because everything else that's more complex can be done better with Bash or Perl. Yeah, sue me. Okay. So, and that's why Perl was invented, by the way, is to replace awk mostly. Anyway, what were we doing before I was bashing on awk? And so, anyway, there are a lot of other things. We're not going to go down the rabbit hole of all the different things that you can use. We're going to finish our task and go of printing out, just the term colors and being able to use that library in other code. That's the main goal for tonight. But we had to kind of do all this other stuff to get there. So let's put this away, and let's say, okay, so we know how to do it in Bash, right? So let's see, using printf to get with \e. I don't know if that's going to work actually. With color escapes and the reset in Bash. Okay, so that, I mean, we covered that kind of. So let's go ahead and do that. Yeah. Well, I don't either anymore because Go and Bash cover everything for me, and the occasional Python, which I have to support. But Perl's still very good. I made a whole video about it in 2022. It still has relevance. I just don't. I hate that I have to say that because I love Perl, but it's just not. There's just too many other better ways to do stuff. Be here on the video. Yeah, absolutely. These notes go into all of the videos, and they are on. They're saved in the boost if you link on 2022. All of the notes and everything are saved. You can go follow it. Okay, so it's just kind of kind of giving you an overview, and I know it's not organized, and I'm just kind of shooting from the hip, but that's just my style. If you don't like it, I'm sorry. Anyway, so let's go back to. So anyway, here's your escape codes. You can just search for ANSI escape sequences, and you'll find them. As you can see, here's the main colors, right? And then they have standard colors and high intensity colors. So I think I already talked about that, but let's just review. Standard and high intensity colors. So in fact, if you know anything about Solarized was the first theme to thumb its nose at ANSI terminal colors, and it actually reused the high intensity colors as something else completely, and that kind of took off. And so in Groovebox, it's not as radical about that, but for that reason, Solarized is called broken by many people. Solarized is a popular theme. I used it for years, and until Groovebox came along. So anyway, these are the colors you can do. I mean, I think you could probably already do everything in this exercise in Bash just from what we've talked about. So let's go back into weeks. All right, so here we are. Here's our term colors thing. So I mean, if you want to do it in Bash first, so let's do that. Let's do term colors just without. I mean, okay, I don't know. Let's make a directory called Bash. Right. Let's make a directory called Bash just for fun, and we'll go in here and let's just make one that does the same thing in Bash, like really quickly. So vi term colors, and actually no, let's make it. And in this one we have to chmod +x. So we're doing it in Bash first, and then we'll do it in Go. All right. So user bin env bash. In this case, I don't care because I want it to work on my Mac, so I'm okay with the lack of security that does. I'll reopen it so we get a color. Anyway, so then we can do, black, right? I mean, you don't have to do it that way. You could do it like black equals, right? Now, this is something interesting. Let's first just let's go back to our printf, right? So printf \e, right? And I'm gonna show you something about Bash that's unique to Bash. That's not in shell. It's all by itself. It's worth using. So left bracket, and I think it was 30, right? 30M. And let's make a clear. So, and then we'll say black or something, and then we'll print the clear, which is 0M. And let's just try this. So /term colors, and we get the word black, and it does what we wanted, right? It doesn't do a line return, so let's go ahead and add that line return there. And then let's do -e 0 M. All right, so that's actually plenty, right? And we can do black. There's our black. Now, you'll notice a couple things. So first of all, this did do an indentation there, which is fine, but that's because we put this space here, right? So yeah. And then let's actually, if we want to, we can actually put the control sequence here. We can actually write it out, right? So if we wanted to include an E in our output, a backslash, we do that and we do 30M. And now it'll kind of give us a prompt for the color we should have, right? So now we get black, and it didn't work. So I have to do 2 of these, I think. Yeah. And this, I'm doing this on purpose because I want you to see that. Record terminal sessions, because it's all on they're all on YouTube. And they're all saved on YouTube random. Yeah, we've been saving them for 3 years now. So if you want to go back and start, you can save terminal sessions using Screen and ASCII Cinema and all that, but we don't do that. Solarize is pretty old, yeah. So that's kind of unwieldy though, isn't it? Right? So, oh boy. What should I check at last? I don't know, man. I don't know. I don't know anything about coding interviews. I refuse to take them. And I'm making plenty of good money. I'm never taking a coding interview. Ever. I'll laugh as I walk out the room. I already figured it out. Okay. So, have fun with that. I suppose some people need it, but I don't. I won't play that fucking game. I'm sorry. It's a ridiculous measure of ability. In fact, it's completely unscientific. And I refuse to play that game. And it's not just because I suck at it, which I do. I swear to God, it's not sour grapes. It's not scientific. It also is probably illegal because it prejudices against people who freeze in front of a whiteboard. And they can't tell you, not being able to freeze in front of a whiteboard is a mandatory work requirement, which makes it illegal to do that. You probably should sue the company. I wish somebody would sue Google, some big company, over this and do a class action for it. I really do. There's people, I've had people that I have dealt with who have autism, who have, some of them have different forms of PTSD. Some of them have, and to say that those people are incapable of fulfilling a job requirement because they can't sit instead of do a fucking job whiteboard interview is unethical and, in my opinion, illegal. There's been people who have a hard time even getting to the site because they're handicapped. There was one guy, somebody subbed after that. Thank you for the sub for that. I just wish somebody would sue their ass. And there are recruiting companies that will deliberately filter out the jobs that do that. Go look for them. There's one in particular, I can't remember the name. I really need to look it up. There are recruiting companies that make their entire point of marketing that they refuse to work with any company that will do that kind of crap. There's plenty of ways to determine your capability without doing that. And it's completely unscientific. It's just because Google started doing it and everybody thinks it's the thing you have to do. And they make jokes about how it doesn't have any relevance to the job all the time. But it's this thing we all have to do. No, it isn't. Just don't do it. Just say no. All right. End of rant. Okay. So, yeah, whatever. Okay. So we have black. What is this one? Let's guess. Let's put question marks here. We don't know what that is. Let's just guess what that one is. What's 31? Let's just guess. Personality assessments are completely unscientific. Myers-Briggs has no basis in reality. It was a fucking game invented by some people to do at a dinner party. It has no basis in reality. All right, I'm off. Callie's like, can you just shut up and keep going now? Okay, yeah. All right, so 31 is red. And I swore a lot. I'm sorry. But I'm not wrong. I'm not on that. INTJ, me too. I'm an INTJ, which I don't think I tested as an INTJ, but I actually think I'm an ENTJ. Anyway, which is why it's bullshit. Okay. Green must be next. Yes, you can probably guess what they are, right? And you can go ahead and finish this. We will do it, right? But before we get too far along, let's let's do something else here. So I want to show you something else about Bash, and then we're going to show you the exact same thing in Go. All right. So, and I knew that we were going to have to fill in the blanks on some of the Bash stuff when we got to the Go stuff, but I've always been a polyglot when it comes to this approach. I do them both. It's how I like people to learn. So the \E, which can also be done as 033. All right. And 033 works in POSIX. See? In fact, let me prove that to you. So let's prove it. I'm pretty sure 033. And you remember back to our ANSI table? Let's go look. You remember the escape? Where is it? Escape. Did I get this wrong? There it is. See it? You see it right there? New subscriber. Thank you. So do you see this 033 right here? Right? Yeah. Okay. So that works in POSIX, and let's actually prove it. Let's prove it. So let's drop our shebang line, and let's not have two like I found in my backup script today. Somebody's backup script, not mine. It just still makes me laugh every time I see it. VNSH. I don't want to talk about it. I don't want to talk about it. Not right now. I'll talk about it during another time. All right. So, hey, look, it worked, right? But watch, if I use \E, SEQ, yeah, that kind of thing, for sure, yeah. Yes, we could. We could use SEQ. We could also do the bash method. There's a lot of things we can do here. The problem is we don't know what the color is that goes with it, right? This man is so charming. Aw, that's very nice. So let's go back to this. Black. So we have black again. Okay, I guess I lied. Maybe it's this line. Maybe that's messing us up. I don't know. All right, let's try. Damn it. I guess I got it wrong. So nothing. It's supposed to break it. I was wrong. I was wrong. So apparently, wait. I don't trust this. I don't trust it. I'm doing my POSIX check. All right. So I'm going to do my POSIX check. So we're going to do Docker. Wait, do we have, so Docker run, I haven't started shrinking yet. rm dash, wait. Run it. That's how I remember that, of course. I am in bash right now. Yeah. But that should have been shell, and it should not have worked because I swear to God, /E does not work in shell. I'm going to prove it. I'm going to run in BusyBox, which is the smallest, most minimal version of Linux or Unix that anybody will ever use. And I mean, in containers and stuff, let's do that. Let's say printf \E 31M, right? Oh, look at that. Look at that. It actually worked. All right. I stand corrected. I stand corrected. So it turns out that \E is POSIX compliant. So I was wrong. I learned something today. That's the X. You see how I experimented with that? The RWX is probably right about that now. I was going to make a big stink about how \E, you should never use that. I can't maintain that anymore. Now you should use that. It's easier to read than 033. They're the same. They're exactly the same. Maybe K shell is wrong. I don't know. Anyway, you see both out there, but I like the \E. I'm going to use that from now on. Now that I know, because I did a test. So whether it's been sh or it's been bash, right? So, and this is the kind of thing, do we really need bash here? Well, yeah. So user bin env bash, because I am going to show you something that will make your life wonderful about bash. Okay. We are going to, before we get too far into all of these, we're going to actually change them. No, that joke is old and tired. It doesn't even work. Because have you done it lately? You want to try that? Okay. I have to do this. We must be on a break right now. So let's take a little break. Yeah. Have you tried it? Have you tried it lately? Let's do it. Let's do it on Ubuntu and see what it does. If you really want to know. Ubuntu, we're on a break, but we'll let the YouTube people still be here on our break. All right. So check it. If I do, oh no, whatever will happen if I do rm-rf/, let's do 10 minutes. So I'll do term down, 10 min, pipe to lolcat for the hell of it. 10 minutes. How about that? So, anyway, so you see what it did? Use dash dash no preserver to override this failsafe. So, sorry, your joke does not land because all you're saying is that you've never known how to do this properly and that you've never actually tried it on something that, and you don't know how to try it on something without blowing away your system, which is what a containers are for, as far as I'm concerned. So you might want to stop with that joke because you're just making a fool of yourself. And I'm not attacking you. I'm not attacking you. I'm telling everybody here that's not a funny joke. Exactly. It's not funny because it's irrelevant. There are worse things, and don't do them, but like fork bombs. There's like a one-line fork bomb that will destroy you. I mean, if you want to really troll people, use that. And every time somebody posts that, I go, okay, you can only put that in my chat if you can explain to me how it works. If you can explain to me how the like 10 character fork bomb actually works, no, not the same. Not even. There's like a 10 character t-shirt worthy fork bomb in Bash that is bad. Anyway, so we're on break. We're on break. Here, have music. Should we put hacker music on? Let's do Devil's Playlist music. All right, I have to turn. Sorry, YouTube, you have to wait while I put music on. The YouTubers have just joined us again, and they're like, "What the hell?" I think we need to have more boosts on Friday night. I think it would be very productive. With Rick, in case you're wondering, you just joined us for YouTube. I'm sorry you missed out. We had kick-ass Devil's Playlist music, Rick and Morty impressions, and vodka on the rocks. So we had a wonderful 10 minutes of like random dancing and everything. So back to work. Yeah, you're gonna have to join us on Twitch if you're gonna want to see that. So I'm not putting that up there. All right, so there's a Marty McFly. He kind of is actually, isn't he? McFly, hello, McFly. No more. Cali Eclipse is like no fun. Like please just stay focused. Okay, fine. Okay, all right. Because you asked. All right, so we need to put an escape here. And so wouldn't it be cool if rather than typing this every time, we could put a variable here? And spoiler alert, you can. The problem is that it's not what you think in shell, right? So you would think that you could do this -e 30 and that would cover you. Yeah. Well, you want more, like no more. Oh, okay. Jessica Glover is like, no. Oh, I know. She's amazing. So anyway, so you got black, right? So here's the problem with this. And I promised you this matters. And this is actually an amazing thing about Bash that I didn't tell you about when we first learned Bash. So this is something I'm going to tell you about now, because now we know all about terminals. We spent an hour talking about VT100 and all how, the history of terminals. So now you get it. So here it is. You put this here. No more. Depends on what. Okay, so if I put the dollar black here, right? Okay, first of all, why is that not going to work? Come on, tell me why. This is like, I know I'm going way back to your Bash knowledge from like weeks ago. Why is that not going to work? I think we covered this. Pretty sure. Why is that not going to work? What's it going to do? There's a problem here. Because black isn't a variable, right? And the little colors syntax highlighting is helping you determine that. In your face, Rob Pike, terminal colors are juvenile. He's quoted as saying that. I strongly disagree. That's a case where the color syntax actually helped you find a problem, right? Because the color got, spread out. So you have to actually put the brackets around it. And that goes for POSIX and Bash, right? So you don't always need to do that. I mean, the Google style guidelines for shell scripting say you always must put all your variables in curly brackets. I don't agree with that. I know. But so, if this works, then, let's make another one, right? Let's make another one called, I don't know, clear. And we'll put 0M, right? So over here, we could do right here, right? So we could do clear. In fact, this one doesn't need the brackets. We don't care about that. And will this work? Let's find out. So, Rick, I'm burping. I'm not supposed to burp. I'm supposed to be suitable for work while I do this, so this shall be a challenge. 19, I accept the challenge. Term colors. And what do we got here? So we got term colors bash. All right, we're in bash mode. So I know we're supposed to be coding Go. I know. I'll get there, I promise. So term colors and watch /term colors. And hey, it still works. Great. And except now let's go back to our good friend Echo, right? Let's change this printf to Echo, which is not uncommon. It is so addicting. Oh my gosh. It is so CodePill, you perfectly said why I am so addicted to Bash and why I have, programs that are like 1100 lines long. If you combine Bash, curl, and JQ, you can do anything instantly, which is great for hackers and other people. Anyway, so you run it, and what happened? What happened? Spaghetti-O. What happened? What happened? What happened? Why did it not work? Why did it not work? So it didn't work because why? Oh, you forgot your -E, right? You forgot your -E. Okay, fine. -E is not POSIX, by the way, right? -E is not POSIX. So \C apparently is. We found that out earlier, but -E is not. So now it works. But then you got this like extra line return and shit like that, right? So, that's really annoying, right? Because you never know. Let's say you want to set up these variables. So this is why Bash really rocks. This is one of the things that it's one of the least appreciated parts about Bash that I'm about to show you, and I just cannot overstate how cool this is. So Bash will actually let you define variables that contain binary data. Okay. JQ, yeah. And I mean, yeah, using those three things, you can pretty much interact with any API on the planet. So, so here's my point. Okay. So let's say you have another program. You're trying to use a library that's got Bash, that's got all the colors in it, or something like that, right? And you want to be able to use those things somewhere. Yeah. And you want to be able to use them everywhere without thinking about whether or not they needed a -E or not, right? An echo -E. You never know. Somebody might use echo. You might use echo and forget the -E, which is not POSIX compliant. Blah 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 blah. Right. So as long as you're using Bash, you can do something different. You can actually get rid of the -E. And a lot of people don't know this, so that's why I'm going to such great lengths to show you about this. And you can change this into its binary. Instead of assigning the string /E, etc., you can actually assign the value by putting a dollar in front, right? And when you do that, guess what? It doesn't work. It's actually single quotes. I forgot. I'm almost positive it's single quotes. Yeah. If it doesn't work, I'm going to be very mad. There we go. So that's one big live demo. It's like total fully risk. So this is the hotness of Bash. Okay. I don't even know what these are called. I just know they exist and they're awesome. So if you put a dollar single quote around a thing, it evaluates this into binary data and stores the binary data in the variable. And so at that point, you don't care. You don't care because it's literally putting the actual binary data output, right? And it's doing the right thing. It's doing the right thing. It does the right thing no matter what. Now, I'm almost positive this is not a POSIX shell thing, and let's actually test that. bin sh. I was positive \E is not POSIX until tonight, so let's test it. And as you can see, yeah, it's not, right? It doesn't know anything about that. It's very, very confused. So that's not a POSIX thing. But user bin, it's an env bash thing. So Bash has a capability of storing binary data. What are you looking at? manual coding in Bash. Oh, look at you. You are the bomb. I'm going to go put that in our notes just because you gave us that. So let's go ahead and do that. Let's put that under related. So I can't tell you how few people know about this. Most people are not dealing with escape data and stuff like that. But occasionally you want to put actual binary data into a variable. And in shell, you can't do that. You can just put a string in there. But in Bash, you can. In Bash, you can. You can put actual binary data into a variable. And that is a way to fix the echo problem, right? So we're going to go ahead and use it. Oh, look at that. I reopened it in Bash, and it actually even has a different color syntax where I did not know that. So, good times. Good times. Expands escape sequences, yes. So there is no escape sequence here to expand because the escape sequence is expanded, and then the expanded value is saved into the variable black. So you don't have to do variable expansion below, which is more efficient. It's easier to do. You can use it with the echo. You don't have to do -e and all that, blah, blah, blah. So I think I made my point on that. So we have black and we have clear and stuff. Let's actually not call this code. Let's call this reset. Because clear is when we want to clear the screen, right? In fact, let's make one for that, shall we? Let's make one. Let's make one. Let's make one for clear. What is it? Do you remember? I think it's 2J. 2J, but we also want it to reset. We want it, I think it's H0, yeah? Did I get it right? So one of the things cool about this is you can actually do that too. So you can echo, let's do that. Let's echo clear black. Let's try this. Let's just see how this does. Term colors. Oh, I fail. I don't remember it. Let me look at my there it is. It's just H and it's 2J. Okay. All right. So it's just H and it's 2J. I was very close, but no cigar. Anyway, so there we go. So that cleared the screen and then it printed it. Now it did not reset. That's weird. I feel like I still failed there somehow. 0M. No, 0M is just reset. You could do 033, but you don't need to. That's /C is the same thing. /033 and /E are literally the same thing. Related to putting binary data into a Bash variable. I don't know of any. If there are, please let us know. I don't know. Bash has been subject to. In fact, before you go away, it's important that you know that bash door or shell shock, I believe the biggest Unix vulnerability in history was based on functions in Bash. So Bash is not immune from security problems over the years. I believe it's, they kind of learned their lesson, and it is pretty damn bloated. But it makes it powerful, and it's also Bash was also dropped from Debian startup and they replaced it with Dash, Debian Alchemist shell, because it's more efficient, and it was too slow on startup. Bash was just too bloated, and so it was replaced. So we talked about that before, but important to reiterate that. I mean there are downsides to Bash, and I'm happy to admit them. And yeah, okay. In the main function, you turn my Bash like C. You even use a main function? Yeah, me too. And we usually will put a function around. Copil, is there an implicit Bash main function that gets called automatically? Normally, and I talked about this when we did Bash programming like weeks ago. You put all your stuff into a function, and then you'll call the function as a thing at the end. So then, in case you have to copy and paste your function into some other code, you can do that. It's already set up for you. Right, as a matter of, and it also helps you scope and lexically scope variables in the same area and all that jazz, right? So why do you care if you're still if you're getting lost? I apologize, but right now it's all about escapes, right? So now you know how to do escapes in Bash. I am not going to finish this program. I'm just going to do black, and I don't know, maybe red. Let's do red. And black and red is all that matters anyway, right? And yeah, so. Let's do red, shall we? I don't know of a way to put the actual data that was not escaped out. There probably is using printf, but I do not know it if it exists. So we're going to put red here, red. And you probably should put clear on its own line. So echo clear. And we don't care about that being quoted because it doesn't matter. And actually, do we want a line return though? No, we don't, right? We don't want an unnecessary line return. So we're going to use a printf. And then we're going to print black and printf black. Then we're trying to make the point here that these are the same. And we can place this on the clear. And you can, we'll have fun with it. I think that's enough for you to know how to add more. I want to get to the go before we get too far along. What time is it? So yeah, we have 9, 10, 11. We have 2 more hours. So let's do the go part on this. I think we have plenty of time to do this. We are mostly covering terminals today. Obviously, that's the point. But I think hopefully this will open up a whole new, even for our existing people, hopefully it will open up a new, interest in you for dealing with a terminal, because there's so many fun things you can do. And God knows we live in a time of, fun terminal hacks, because so much is on the terminal these days. Thank God. Can I just say how grateful I am for that? All right. So that did not work. I broke something, obviously. Oh wait, we're printing off that's right, because I did clear instead of reset, because I'm not paying attention. Here we go. Reset. I have Twitch brain. It's called Twitch brain. I have 2 blacks. Do I? I do. Look at that. Look at that. Thank you. I don't have red. Oh, I have 2 blacks. Thank you for pair programming my way to happiness. We've been pair programming at work, and I got to tell you, it is worth it, man. If even in operations, like if you're an SRE, pair programming is really good, because you know things that the other person doesn't know, and you combine them and you check each other like you guys just did me, and it's amazing. We're writing this really, really complicated, crazy ass important REST API for our batch processing operations, and I cannot express my gratitude for the opportunity to pair program that shit, because people see stuff that doesn't matter. Look at that. It put 2 dashes, it put slashes there. I only need the 1. So now I can get rid of this one. All right. So there we go. It cleared the screen, but it did not reset. No, it didn't, right? What am I doing wrong? What am I doing wrong, everyone? Type C. No. Yeah. C is a thing. Oh, did I forget the bracket? I think I did. Bad me. I did. I forgot the bracket. All right. So this should do it. And we can be on to our Go programming. There we go. Terms. Okay. Boom. Boom. Right? Oh, wait. What's up with red? Why is red broken again? Red's broken again. It didn't print it. What the hell? What the hell? Oh, and also, it's because echo. It's because echo. All right, printf. We'll go back to printf because printf is reliable. There we go. Black and red. And now, of course, we need our other escape in there. All right, that makes sense. Yeah, because we didn't have there. All right, so and I mean, if you want to, you can get crazy and make them like line up and crap so they look nice. You probably want something like this because you can actually just cut and paste from it. In fact, let's do that. Let's make it so it prints out code that can be cut and paste into a script. Let's do that, shall we? And then you could say, it was just in lowercase, black. Yeah, I mean, that's more valuable, right? This other thing is not so valuable. But this is, because now I can use it as a, in fact, let's go so far as to actually make it legit shellcode. Oh my God, my mind just exploded. Yeah, watch. So now I've got actual code. No, I don't yet. I'm getting there, I promise. Okay. Let's do this. Ooh, golly jeepers. You see what I'm doing here? Or I'm trying to do anyway. God damn it. There you are. Yeah, what I'm trying to do here is this. I'm trying to make it so it produces code that I can cut and paste. Why? because then whenever I'm doing a shell script, I can just dump it in there and I don't have to do it every time. Yeah, I'm making a shell filter command. Or, it's not really a filter, but yeah. So let's do that. Oh, look at that. Okay, we don't want the dollar sign there. Dummy, right? We want to get rid of those. We can do that. All right, so now check it. So now we can actually make foo. We're going to make foo here, schmox foo, which is schma plus x. In case you don't know, I'm just lazy. So vi foo. And then we do user bin env, or not if you don't want the security issue, right? User bin env is insecure, the end. If you don't understand why, do the research. And okay, so we're gonna go ahead and put this here. So I'm gonna do bang bang, and I'm gonna type /termcolors. Boom. And I have a problem. Why do I have a problem? Because it literally dumped the actual escape sequences in here, right? And I actually did this on purpose because that's not what you want, right? You don't want that. So our thing is not quite done yet. We need to override these values, right? And so we actually want a condition. We want to say if test -t1, then this, right? And what does that do? Anybody remember? What does test-t1 do? If you don't know, man test. We're going to go look for -t. What is this -t-ness that we're talking about here? -t. Okay, -t gives you a file descriptor. FD is opened on a terminal. So that means that the program is running on an opened interactive terminal. If it's not, then we assume that it's a filter in VI or it's being redirected or all that stuff. If you're going to get into color, you need to know this. And I'm going to put it in my README, okay? Because people make this mistake all the time. Make sure to detect non-interactive terminals and disable color. If you don't do that, you're a horrible person. Because you will end up causing people to have these crazy escape sequences for colors stuck in their dumps and their redirects and stuff like that. All right, and we're going to do this both in Go and in Shell, but I'm going to show you how to do that. It's not hard, but you just need to say, okay, if there is a file descriptor one, then we're going to do this. Otherwise, don't. And let me make sure I got that right. I have this already in my. I already did this particular program. So there we go. We set them all up, and then we do T1. Okay. And actually, mine is not even doing the cool way now because I know about printf. I don't necessarily need to do the other way. I'm doing the whole double quoted thing, which is fine. But anyway, so and the variable scope on these is. So if you use black without that, it should be fine. We actually don't even really need to do the initialization, I don't think. So let's try foo. /foo. Plain text form with color supports the terminal output could have its own color preserved somehow. When redirecting the extra work, plain text already supports pictures emojis with no colors. Well, that's try it. Yeah, emoji for sure. But emoji is just another text character, right? They may eventually do it, but they certainly don't have that now. So as you can see, it didn't blow up, right? So here we go. Bang bang, ./termcolors, and yay. Okay, so now it didn't work because I have a problem in my code. And if you don't know what I just did, you need to go back and watch the VI stuff, right? We spent an exhaustively long amount of time on how to do filters and why you care about filters, etc. So we're not going to go back to that, right? So vi-foo, we're going to use a filter which is just bang bang, and then we're going to run it ./termcolors and replace the current line with the output of the program, and we get this, right? So that is why you might want to make one of these. Oh my God, it's too bad. So anyway, now I can actually use these, right? So I can say echo even, and I can use echo. I don't have to use printf, right? I can use my favorite echo. This is darker, and we'll put it black, and we'll put, we don't have a reset though, damn it. We need to add that. I mean, you know, let's just test it. So /foo, and we got, this is darker, so we get our color. Yeah. And if you want, actually, if you want a bonus project, let me show you something fun. So I actually made a program called Mark in Bash that does markdown parsing in the terminal, and in order to provide colors and bold depending on markdown. So it was really fun. I really enjoyed it. Here's the peg for it. And if you know markdown, we've covered markdown already. So this is actually a totally Bash the recursive descent parser that will convert anything. So you can say mark some thing with different colors, and it will actually do it. It will convert it. And I got to tell you, if you want a fun project, I know we're just doing terminal colors right now, but if you ever want to try your hand at parsing and recursive descent parse, that's all in Bash. And it's in my dot files. If you want to go find it, you can go look for the mark command. So once I have that, I can actually write a ton of utilities in Bash and just use Markdown for my color schemes. And I don't even have to use all of the term colors like I've been importing. I can just use it that way. And then when I print stuff, I can just print it through Mark. I use user bin env, so it finds Bash and user local bin Bash, which is where it lives on Mac versus where it lives on another thing. We're still on Bash. We're going to get to go. Don't worry. All right. So you have to understand all of these things about term colors before we can move on. You just do, right? You need to be on Go. Oh, do I? Yeah. Yeah. I guess I do, huh? Because you said so. I need to be exactly where I want to be. Cheers. Okay. So, anyway, yeah. So, you know, if you're looking for like managed content and organized stuff and continuity and things like that, and you need to go someplace else. All right. So if test st, then black, red, reset required. So this is the precursor. Now, this looks like it was a waste of time, but I promise you it's not. Because when we do this in Go, it's not as simple as this. And now you have it in Bash. You didn't have it before. So now, you know, you learned Bash already. It's on the boost. So now you have that knowledge for Bash and Shell, which is added to your, you know, Bash knowledge. Now we're going to add that knowledge to Go. And we're going to do exactly the same thing in Go. We're going to learn how to do escapes and all of this stuff in Go. So now you have a point of reference. And every other case, when I would do something in Go, like with greet and hi and hello, you were able to refer back to your code in Bash and go, oh, I could do that in Bash easily. I know how to do it. But you didn't know how to do that in for this stuff. So I had to like supplement it. So anytime there's a deficiency in your Bash knowledge, I'm going to fill that in before I do the Go stuff, if possible. There's some things in Go that you can do that you can't do in Bash. And we'll get to those, but we're not there right now. Not many though, believe it or not. There's not many limitations. Anyway, so, okay, here we go. We got our term colors. Bash is done, and it's time to move on. So let's do the term colors and Go, right? So the first things is first, how do we assign a variable? Let's assume we want a constant. And by the way, what's the difference between a constant? It's the first time we've used constants in Go. Bash does not have constants. That's not completely true. You can use read-only. There are ways to make things into constants, but they're not like, you know, explicitly supported. What is a constant? What's the difference between a constant and a variable? Somebody spit that out. What is the difference between a constant and a variable? And why do we care? I'm going to drink vodka while you answer. Come on. Yeah, I know you got something for me here. Somebody's got something out there. I know you do. I just got to wait. Value can change, which is what you would want for a color. Yeah, cheers to that. All right, so constants do not change. Yeah, I mean, it's pretty obvious, right? But I think it's worth saying and it's worth remembering that constants don't change. Constants are immutable. There's the fancy ass answer right there, right? Immutable literally means cannot be mutated. And if you've seen any sci-fi, you know what happens when you mutate something, right? Like the Toxic Avenger. The Toxic Avenger is a mutation of, a human being, right? It was changed. It was like radically, horribly changed. I am deliberately picking these like crazy, crazy mnemonic devices so they will stick in your brain on purpose. Every time you think of immutable, you're going to think of the Toxic Avenger. And if you don't know what the Toxic Avenger is, I'm going to hammer this home. I really am. I'm going to bring this thing home. So every time you think of Avenger, every time you think of immutable, I want you to think of the Toxic Avenger. All right. You're going to see the Toxic Avenger's face and you go, the Toxic Avenger was mutable. The Fly, he changed form, right? He's a mutation. A mutation is a form. And if you are going to get into Rust makes a big stink about being immutable, right? Containers, ephemeral and immutable, right? Functional programming, immutable, right? So you just have what you have. So mutation is something changed, right? And we're going to go back now. So let's do constants and mutability. The mutability is the big fancy computer science term for, hey, you can change it, mutate it, right? So only mutable values that can change, yes. Okay, so we want a constant in this case, right? Is there any chance we would ever want to change the value of the escape sequence for black, for example? No, we really don't. We really don't. So this is a constant. So this is the first time we're going to do constants, right? Now, you can do a constant on a line by itself. Yeah, there's no reason ever. And so this is an important, I'm taking you through the thought process here. When you're defining things, there's some people that might put that, by the way, this goes for JavaScript too, right? So, or most any language that supports it. Thank God JavaScript does now. You should always use const and var. Const and let, I'm sorry. In JavaScript, by the way, if you're using var, you're a bad person. You should be using constant and let if you're using JavaScript. Just putting it out there. So we're gonna use constant. We're gonna say constant. Black will say, and we don't care about it being lowercase because it's gonna be termcolors.black. I'll show you that in a minute. Var global scope, hell no. Var global scope in Go has many significant uses. Yeah, but and I use it a lot in ANSI, but not in here. In JavaScript, maybe, but usually not. Identifies as red. Good point, Borky Bash. Yeah, we're going to be intolerant though tonight. You were born black. You're always going to be black in this program. I'm sorry. I know that sounds so horrible. I'm sorry. Anyway, so black equals what? All right. So now we need to figure out what the string is going to be, right? Well, it just so happens that, hey, there's a dash E also, but it's not what you think. So I'm going to prove a point. So slash 30 M, right? And let's make a reset, right? And I'm making some mistakes here on purpose that I want you to catch later. Yeah, I've already made a couple of mistakes that I want you to catch. Okay, so anyway, and we're going to, please let's not turn this into something negative. I don't want to go there. So let's do that. Let's say, so now we need a test case, which we already did. How do I write a test case? How do I write an example test case? We did it already. I want to test this awesome code that I just wrote and go, how do I do it? Right. It says unknown escape sequence. Damn. All right. So it turns out that we don't want \E in Go, right? And guess what does work though? 033, which is why I showed you. Okay. This actually is something called octal notation, which is base 8, if I remember right. And we haven't got there yet. We're going to make a program that prints decimal, hexadecimal, and octal, but we're not there yet, okay? So we're going to use octal notation. Octal notation always begins with a 0 in Go anyway, and bash. So that says we want whatever the escape sequence is that is represented by the octal number 33. And so then we get this, right? And now we have something that works. So now we can go back into our stuff. We're on week 19. And we go into term colors. Oops. Damn it. What's up? Oh, damn. I did a bad thing. Okay, so then we do, okay, so we're going to make a test case. Remember how to do this? So we're going to make a file called termcolors_test.go, which is the standard convention. And that actually is read by Go test. So you need to have it be that. And then we're going to call this package termcolors underscore test. Now, the reason we do this is because, and we talked about example tests already, but by doing that, we end up creating examples that double as tests and documentation examples that are exactly what a user would type in. So we did type example, and we're going to type well, we don't have a function here, right? So we could just have just a plain old example if we wanted to, but let's do what else can we do here? Let's say let's say black. And you already see a problem immediately, right? Anybody can see it. I did it on purpose, but can you see a problem with our test case? Right? So fmt_println, we already covered that last week. And I can print black plus black equals whatever. Actually, I think we can actually get the actual value of it. I think we might be able to do that, actually. Let's try that. You guys know about printf yet? We haven't used printf yet, so let's still do that. So plus, let's just say black for now. And then reset, right? So now what? So let's run this. Go test. Can't do it. Don't have any idea who you are. Uh-oh, we forgot to initialize our module. As you remember, way back when. So go init. I'm just going to do it. You should know this. We covered this. So go init, and then we need to give it the full path. So I'm going to pwd this so I can get this right, type this all out. It's pretty long. And yes, you can have multiple modules in the same Git repo. It's unusual, but you can definitely do it. So go init, go mod init, init, yes, go mod init, and you can't just do that, right? You have to tell it what you want. So that's why I typed out the pwd, which is off screen now. Okay, so github.com/rbx boost rob /boost. Usually will be different. Weeks 19 /termcolors. Right, so that's the name of the package, and you'll see that we have a go.mod now that's right. Now I can do go test, and will be happy. Undefined black and reset. Uh-oh. Why? They're not public. Good catch, recursion tree. They're not public. What does that mean? The variables of PWD. Yeah, I could have actually. Yeah. Well, no. I mean, I would have had to cut off this stuff at the beginning, right? I would have had to cut off. So I went ahead and typed it. So yeah, we need to export it. So you may remember this, but any symbol whatsoever, whether it's a function or a variable or a constant, doesn't get exported and accessible to other things unless it's capitalized in Go. And you can hate that all you want. I love it. But that's the way it is. It saves me from typing export like you'd have to type in other languages, right? Now, the reason that, let me just remind you. So the reason that our package for this actual library is termcolors, yeah? And our package, oopsie. And what am I doing? I put capitals on. I'm an idiot. All right, so our package is actually termcolors up here. Why did I put _test under here? So as a review, the reason I put _test as a convention in my unit tests is because this is a thing that Go allows in the unit test that says deliberately make this a different package so that errors because I didn't export something and make them public will be caught. Watch what happens if I don't do that. I want you to see this. If I, and you can write tests, so the point I'm trying to make is you can even write example tests that test private stuff. Bad idea to do this, but you can do this, right? And that will do it. It'll run and say, oh, I didn't see any tests to run, but it didn't get any errors. right? That's a bad idea. That's a bad idea. In fact, especially if you're doing example tests. If you're doing example tests, and we haven't done the other type of test yet, but if you're doing example tests, you should always put underscore test in your package in your package line, because that's going to catch those export errors, right? Like it did for us. And then you can, the tilde, by the way, it just folds the case and makes a capital in Vim. And so then we can go test and it'll actually pass, or it should pass. And it's not passing because why? Because we changed it in the code, but not the test. So let's change it in the test. We'll go to the test and we'll change black, and we'll do a tilde to change that. And we'll do a tilde to change reset. And that's not enough though. It's not enough. Is it going to work? But we don't want to export this variable. Oh, we absolutely do want to export this variable, because we're going to be using termcolors.black and reset and all of that stuff in our programs from now on. And that's the point of this package, of this library, right? So we want to be able to reuse this code all over. And so we're going to go test, and we get undefined black and reset. What the hell? Why can't it find it? Well, when you have an exported thing that's coming from someplace else, you need to tell it what it belongs to. Term colors. Now that's kind of annoying to type. And I'm going to show you something that you don't know yet. You haven't learned yet. All right. It does need the package, exactly. And I don't know if you noticed, but because my Vim is set up properly, and we covered that already, it automatically adds the import line. Having to type that import line every time and delete it when I'm not using a package is so annoying. I would never code and go if I had to do that every time. We're not using testing T. No, we're not. We're using example tests only for now. Testing.t, in case anybody knows, is using the testing library, which people generally teach you first, which I think is a huge mistake. Because example tests, you get documentation and testing at the same time. If your test does not fall within the ability to represent it as an example test, fine. We can go to testing.t, which we will do. And if you know go a little bit ago already, you already know about this, right? But defaulting to that, or I've actually timed out somebody for recommending Testify last time, or an entirely external package. You're going to build this bloated external dependency on some dumbass testing library. You're doing it wrong, in my opinion. You start with the simplest test cases that allow you to produce documentation at the same time. And as you outgrow them, progressive design, as you outgrow them, then you layer in these extra tests that you need, in my opinion. Nobody's doing this, by the way. Nobody's doing this. It's a big, I need a drink. I feel better. Okay. People are just like, fuck the user. I don't care. And they're writing these extremely complicated test cases that are completely indecipherable. It's like, they might as well be writing Perl code. Yeah, I did that. I just did that. And it bothers me to no end. And speaking of something that bothers me to no end, who the hell is going to type termcolors.black, termcolors.reset every time they want to use one of these really pretty constants? Nobody wants to type that, right? And I also don't want to change the name of my package, because then it would be, too terse. So there is a way to do an alias. This is the first time you're going to see this, so I'm going to put it in README. Import aliases, package aliases. Okay, so what you need to do is to say, okay, I want to make aliases. Now, you got to be careful here, because, if you might have something really small, but you could stomp on something, right? So if I were to just do C, I mean, that's a single letter. It's very likely that something else in this file, not package, file, something else in this file is going to use C, and I'm going to stomp all over it, right? Now, usually you're going to be okay to do that even, but let's not. Let's make it a capital C for grins, shits, and giggles. It doesn't get exported, so it's just an example test, right? We don't really care. But, you could use that if you wanted to, right? Now, this is a test case, so, and as soon as I saved it, it overrid it. It said, no, you don't use that, right? But if I put a capital C there, and then I change term colors to capital C, and I change this to capital C, that will keep. And now, it's kind of controversial to do this in an example test, because the person reading the example is not going to see that C was the alias, So if you're going to do that, you might want to put in your example, you might want to put something like term colors aliased to C, right? So, or you can copy this because when they look at the example in the documentation, it's not going to have the import lines. It's only going to have the content of this block right here, the stuff inside of the example. So you might put that there as just as a reminder to everybody that's how it was aliased. So when they see this, they're like, where is the hell is C coming from, right? In the example test. So now you go test and it should all work. And there's no test to run, right? We didn't really do anything in our tests, but it printed. Now, how the hell would you actually test this? And this is where the stuff gets really interesting, because the tests, when the test cases run, they're not running as interactive terminals, right? They're running as quieted terminals. So this is where our example testing starts to fail. And it might be the opportunity for us to start to talk about the testing framework, which is a different thing. It's a built-in thing in Go, but we might be outgrowing our example test here. So in that case, you might want an example test that doesn't have output to demonstrate how to use it. But it's gonna watch. So I mean, there's a couple things here to look. Whoops, I got my. I turned caps lock on like an idiot. Okay, so here we go. So output. So output blah, and let's run Go test. Damn it. What did I do wrong? Output blah. Again, that's going to show up as an example. Oh, we killed our. Okay. So Go test. Thank you. So we're going to do Go test now. And we get blah. And it printed black and not blah. Now, this is interesting, right? Look at what it got. It got the example test. So this is where printf %q comes to the rescue. I cannot tell you how cool this is, right? So instead of doing println, we're going to do printf, right? And we're going to say, we're going to do printf. Now, printf, as you know, will print out the actual value. So the exact equivalent of printf and println. So the plus, by the way, is just a joiner. It just joins it together. It's actually faster than printf, but it's fine. The V is going to say, replace this with the value. So we're going to alter our test case here, and we're going to do it this way, right? So, and here we'll put the word black. We don't have to worry about the curlies, and stuff like that, because as the colors are indicating, %V is observed by Go, and so we can just write it that way, right? And you probably know where I'm going with this. We can actually make a loop eventually, right? So let's do Go test here. And as you can see, we need 2 arguments and I was given 3. Okay, well let's change this center one to V as well, right? So now black will go into the first V. I'm sorry, C.black, the escape will, the opening one. The black word, the string, will go into that one. And the last one will be C.reset. And now that I look at it, I realize there's no line return. So we'll add a line return. And we're going to, and we see that, hey, it still printed it, right? But how am I possibly, in my example test, how am I possibly going to match black? If I put black here, it's not going to match. Why? Why isn't it going to match? Because it's not colored, right? And I can't really, I could try to put the binary for that in here, but that kind of starts getting weird, right? So the secret to this is to use Q for our escapes, right? And if we use Q for our escapes, you'll see that the test gets escaped. And this is what I wanted to show you too, that yet another way to write this escape value is hexadecimal. So let's go back to here, and you'll see here's escape, right? Escape, there's our 033, we covered that one. We covered \E, which is just generically understood by bash. And we covered, and now we're seeing 1B, which is hexadecimal. So if it's octal, it's 033. But by default, Go is pretty good at representing something in the smallest possible way, taking the least number of digits. And so it says, okay, fine, I'm going to show you that in hexadecimal. So %Q, the moral of the story here, is that %Q, use %Q when testing escape output. Okay, because if you're using an example test, not only are you reiterating to the person using your thing that these are escape sequences, but you're also reminding them the actual value. And that's all in the documentation. So it's absolutely beautiful because you can actually say, oh, okay, well, and now you can change your test case to be, to have those things. Now, if you want, you can do all of this at once, and that's probably more efficient. Those quotes are a little confusing, right? So let's change that. Let's change the test case. So let's go down here to the test case, and we're gonna say, God, can I still use my F? Yeah, we can. Let's quote the whole freaking thing. But instead of using commas here, let's actually put pluses back in, right? So now it's just one big old string. So that stuff all gets combined into a big old string, and that big old string gets printed out and quoted appropriately, right? And it's much easier to decipher when we do that. So now we do a go test, and we get this thing, right? And that's something that we can cut and paste into our test case that will always be consistent, whether or not there's color support in our tests, and can be read and deciphered by our end users in the documentation. So we replace black with that. And now our test case passes, should be anyway. So now it passes, right? Because our test case is saying, okay, and and I mean, look at how illustrative this example test is. You look at this thing and right away you know what's going down, right? And you can even see the value. So you may have forgotten while you're looking at the example test, saying, oh yeah, that's right, 0M is reset, right? And you can actually immediately understand it in the documentation. Now I know you haven't fully appreciated the documentation, but let me just take a moment to show you why. It's kind of a refresher on the last thing. But if you go to go.doc, I think it is. Go.dev is documentation for the Go programming language. Actually, it's package.go.dev is the one. So this is where all the documentation goes, right? So if you go in here and you look at like example.go, so you have these big ass examples that are not necessarily the same thing, but let's go find something else. Let me find anything else that's got example based go tests. Let's go to actually RDBX rub / struct. I think my stuff might be here, actually. Some of my stuff might be here. Let's go see if we can find it. I don't know. Let's see. Where's the search button? I spent a long time since I used this. Jump to RDBX rub. Wait. Is this only in this one? Go docs, package, standard library. Where's my stuff? Actually, I think it's on GitHub. If I go to github.com, I have a link. I generally put a link. Structs. And so here they are. And I think I have a link. Yeah, there we go. Go reference. So you click on that, and you should probably put this in your code. I'm kind of getting ahead of myself, but Go report card has no idea how to handle Go 1.18. Yeah, which is totally true. That was my own comment. So here's the different directories. Let's look at a QStack, which is kind of a queue and a stack combined. And here, look at all of these pretty examples I get for free. These are all my tests, right? So I tested my fields thing. So here's my fields, right? Here's my QStack. And I have my thing that I wrote here. This is a long form example. If you just make an example that does not have, something after that, you get one of these. And then it shows you the output. But let's look for something that's more specific. So here we have one that actually executes. So this says func main, but it's really not func main. If you were to look at the test case, you would see that it is, thank you for that. It's actually other stuff here. So we have print and fill mains, and then we have the output something, right? And the thing that's really cool about this is you can't do it right now, but if you can actually run it, and it will go to the remote server and it will generate the output. You can actually change it. So you can say some other thing and click on run, and you can do that. That is one of the single coolest things about Go, is that the playground has been around, has been supported by Google forever, and you can use this to create interactive examples of how to use your Go code. How cool is that? I mean, seriously, why would you use anything else? If you can make your tests in the form of examples, why the hell would you not do that? Because I tell you what, if you use a testing framework or Testify, you cannot do this. And I think it's throwing away a wonderful opportunity to create really clean and clear code that anybody can come in and understand immediately by just looking at your examples. I hope I've made my case, because that is, I think, something of a rampant problem in the Go community right now, is this overcomplication of test cases. Yeah, I needed a drink after that. Okay, so anyway, we got this nice clean code that's going to appear, and we have example black, and it shows how to use black and reset, blah, blah, blah. I think that covers it, right? And so the rest of this is actually pretty easy. We're just putting constants in this package. That's it. Could we do it by, actually, this is a case where we can actually write code that writes code. Yeah. You want to do that a little bit? You want to try that? So let's say for I in, we'll write some bash, 1 ... to 8, let's say, right? Do, and I know it's not going to do because we're writing bash and go, which is weird, right? So we're going to say do printf. We're going to say const, and I guess we'll just say black. We'll change the names later. We can't, unfortunately, do that part of it. So black equals, and then we'll have a backslash to escape that. And then we could use 033, which everybody knows, or we could use -x1 whatever. It doesn't matter. So you can use whatever. We'd use -33. We do need to put 2 slashes there to get the actual slash though. And then we need a left bracket, and then 3, and then the number. So this is where our I comes in. And then M. So we're going to need to put that inside of quote. This is why learning bash is so important. And then we're going to do another double quote, and then we'll have a quote here. And so I bang bang bash that, and I should get a syntax error. I forgot done. All right, so bang bang bash, and oh, we forgot a line return, right? It's not quite doing what we want. So let's do that. We need a line return in here. So let's see if now that works. Bash, and we get, oh damn, it's pretty damn close, but it's not it. You know what's weird? It actually printed the escape. By the way, that's valid Go code. That's valid Go code. We actually put here, let me do that again. You see this? Anytime you see this in code, that is not a caret and a left bracket. That is the representation of an escape in VI. Let me show you something killer about VI. So let's say we open up the ls binary, elf binary in this. You see all of these carets? These carets are basic bash for sure, and then Python, in my opinion. You see that all these carets are telling you, hey, there's binary data here. I can't tell you what the binary data is. It's kind of weird, right? You could literally change the binary data in VI, which is just freaking awesome if you ask me. I love that. I really love that. Anyway, so let's go back to this. We did this auto generation, but it didn't quite do what we wanted to, right? It actually printed the actual escape value, which we don't want. I mean, it's totally valid to do that. Go will accept binary representation like that, but everybody would hate you because they can't read it, right? So we need to put another backslash in there. And then we run that bash through, we run this line through bash. This is a filter, bang, bang, bash. So bang, bang, what that does is it sends the current line to whatever I type, and then it replaces it with its output. So it runs the bash code that replaces it and writes code from code. Pretty damn cool. And that's why you don't need plugins and shit. If you know how to do that, we talked about this in the VI times. If you know how to do that, if you know how to write bash really well, you can write bash to write your code in your Vim without leaving the session. Why would you not do that? Why would you write a Lua plugin for something? I mean, why would you go to the hassle of that? Why not just get really, really good with bash and then write bash to write your code? Or Python, who cares? Any language whatsoever. Okay? I get kind of spun up about this because it's so obvious and so awesome, and people just throw it out the window all the time. Yeah, VI is Vim, yeah. And it's the same. They're the same. My hands are just, addicted to... So now I couldn't change black, so how are we going to do that? We're going to do /black. slash change black. And we're going to go to the next one, next, and we're going to change CW to change the word. And we're going to change this black to the next one, right? Which is red. And I don't know if that's it. And we're going to N to go to the next one. And we're going to change word for whatever it is. What's next? Let's go find out what's next. I don't know. I don't remember. Do we have it up here? Oh, ow, my eyes. Did I delete it? I think I did. Do you guys remember it? What's the next one? What's the next one? Someone tell me. So, ANSI escape sequences color. I don't remember them. I mean, I have them already. Okay, there we go. Oh, look at that. It's like a first hit. Bright is, so we got red, green, yellow, and blue. So 0 is black. So red, green, yellow, blue, and I think it's cyan, magenta. 4 more rows. Yes. Red, green. All right. So we have black, red, green, yellow, blue, magenta, cyan, and white. Magenta, cyan, white. White is 7, yeah? Oh, I got them wrong. So 0 is black. All right, 0 black, red. 1 is black, red. Oh, wait. What? 1 is red. 2 is green. 3 is yellow. 4 is blue, magenta, cyan, and white. I guess there's not a 38. All right, so there's not a 38. Okay, so let's do that. Oh, thank you. Thank you. So there we go. So we got there's our constants, right? We have reset. If you want to put clear in there, you can put clear. And you remember clear, right? So clear is H and 2J. And 2J clears the screen, but H puts it in the top left. So that's the same as running, typing clear in the terminal. So you can put clear in there, right? Now, if you want to, you can get creative here, right? So you could make 2 constants. You could say that black equals that. You could say, it turns out that these are unique, and you could have a green, you can have a yellow, you can have a blue, be B. I love that the names don't. I happen to know that they're not going to collide. Cyan and then white is white, and reset is reset, clear is clear. I mean, we're not going to. If you wanted to, you could do. I actually have an X for clear. Actually, no. Reset. I made an X for. So I mean, it's whatever you want, right? It's your thing. So we're gonna make X for that, and I think we're going to leave clear there, like for clear the screen. So we'll leave that to be a long one. But that's going to make your code a lot smaller, right? If you wanted to, you could make those constants equal the other constants. So if you change the value, it gets inlined. I mean, if you want to do that, you can do that. It just gives you an alias, so you only have one thing to change. They're not going to change though, so it's really not worth it if you just copy the line. It's the same, by the way. It would be inlined by the compiler anyway. And the constants are always inlined by the compiler, which means that any place they occur in the source code gets replaced directly with the value. So it's not getting evaluated at any point at runtime, which makes your code much faster. So you always want to use constants whenever you can. And then they go into a different place in memory, which I think is the stack and not the heap. But I don't remember. That's why I have to go look to get better at my C. Anyway, so that's really it. That's all we had. Now, you can have functions that do the same thing. And by the way, if you look around in the Go ecosystem for colors, there's a ton of shit like this that will have you run a function for each of these. And the function will go out and get a value that's not even a constant, and then it will price. It's completely inefficient and stupid, frankly. It's just stupid. Why? If you know that you're on a standard terminal, why the hell would you cause your text-based rendering to have to go out and call functions every time it wants to change the state of the color? It's totally stupid. And there is tons and tons of code that has that. When in fact, now that you know, if you can assume that someone's using the proper terminal, which I suppose you can't do, and that's why somebody abuses the function unnecessarily, in my opinion, you can go out and you can just print the constant in the string. And you don't even have to get fancy with it. You don't have to have a green function and a yellow function, all that crap. You can just do it. You can just print it. It's a pet peeve of mine because it's like so wasteful. It's so stupid and wasteful. Okay, where's my drink? All right, termcolors test. Let's do this. So we got black in here. Yeah, let's actually add our other ones. So I guess there's 5 or 6 of them. So there's no easy way to do this, unfortunately. So, and we're almost done actually. So we have black, and so we're gonna change black to red, blue. What was the next one? I want to say magenta. Yeah. Did I get it right? Damn, I can't remember. Oopsie. Load file. Yeah. There we go. Black, red, green, of course. Green. I'll get to the other one. Don't worry. And we're gonna use G2, and we're gonna show off all of the things you can do here. And red. I mean, it's annoying, but we have to do this. Black and blue have the same initial cap. I didn't realize that. So let's do BL. I don't think I've ever done black and white in any of the things I've done before. So this is kind of interesting. BL doesn't help us, does it? All right, screw the small letter ones. We're not going to do that anymore. As of this moment, I've decided to stop doing that because it's. I mean, the reset is kind of nice. The X is kind of nice. Let's keep that. No. I'm going to make you write longhand code. So there. You can hate me all you want. I don't think I ever had, because I never had black in it before. This is the first time I put black. And I know there's all kinds of jokes you can make there, which would be horrible. But so we have black, red, blue, green, yellow, magenta, cyan, white, and that's it. So, and we'll do the same for these. Blue, green, yellow, magenta, cyan, white. And we haven't even covered bold yet, which you can do. I'm not going to do it, but you can do bold. And you can combine them, actually. Yeah, you can combine them. It's kind of cool. You can do underlining. You can do italics, depending on if your terminal supports it. And there's no way to test if your terminal supports it, unfortunately. So there's other cool things. We'll wait on those. You can do blinking, too. Yeah, which Alacrity doesn't support. Another reason I dropped Alacrity. So what? So we have black, red, blue, green, yellow, magenta, cyan, and white. All right, so black. I wish this could be automated, but it can't. So black, red, black. Oh, my wife's home. Green. My wife's home, so it's almost time for me to be done. What time is it? 9:48? Hell, we got an hour and 10 minutes left. Okay, God, we're going fast. We're going to finish 9cat too. All right, so black, red, green, yellow, magenta, cyan, white. Yeah, she's going to make us some big meal. It's going to make me fat. Go test. So there we go. What is our test off? So we have black, red. Oh, it's 31. I didn't change the number. What? What did I forget to do? What did I forget to do? Oh. Replace the 1, replace 2. R3, R4, R5, whoops, sorry, R5, R6. Test, pass, please. Damn. We're getting close. We missed 37. 3, 4, 5, 6. What did I do wrong? 1, 2, 3, 4, 5, 6. Red, green, yellow, magenta, cyan, white. Oh, black. Oh, blue. We forgot blue. How possibly could we forget blue? We forgot blue. All right, so there's actually a way to increment a number when you're hovering over it, and I don't know it. I don't remember it. I do it on accident all the time, though. Does anybody know it? There's a VI way. If you're hovering over a number, you can press something, and it will increment the number by 1. I don't know it, though. I do it on accident. So go test. Oh, we still have a problem here. I'm going to zoom in because I need to see the whole thing. That's leader Z in this case. Control A. Is it Control A? Is it Control A? If you haven't modded Vim, it's up arrow. Seriously. Huh. Oh my god, it's up arrow. It's up arrow. Oh my god. Oh my god. Thank you. Thank you. You get rep for that. Yeah. You get rep for that for sure. Thank you for helping me out with that. So yeah. It's weird because it thinks it's 41. Oh my god, that's so weird. Okay, well, all right. So 32, 33, 34, 35, 36, 37. How is blue 34? I don't believe you. It is. It is. It's like right there, and I don't even have the way. Yeah. Why is blue 34? I'm missing something. Did I get it wrong? 30, 31. Oh. Okay. I it's late and I'm sort of drunk. Not drunk, but 31, 32. Oh, so green is next. Oh. Green, yellow, and then blue. Of course. 31. Hey, look. I used my new thing. Yeah. 33, 34, 35, 36, 37. Thank you for showing me that. That's cool. Go test. Damn it. I am so close. I can feel it. 1B. Oh. Red, green. Hello, you. I have an hour and 15 minutes of boost to do, but I'm going to take a 10-minute break here pretty soon. Okie dokie. My wife's coming to report. Red, green. What the hell? Oh. Red, green, blue. No. Yellow, blue. Red, green, yellow, blue, magenta. I mean, this is taking too long, but whatever. Yay! All right, so we have a successful test case. That shows off our cool new thing. And that's a kind of a good place for a break. So let's actually do a working commit, which is a way to save your ass. If you're going to go away and you come back, you don't know what you did. So git status, we're going to see what we did. We're going to git add. I mean, we should probably add everything. Git add -a dot. We say git commit -m. Add initial term colors. git push. So this is now in the boost. As you know, you can go in the boost and get that code. It's under the 2022 branch, which is linked from the README there. And on that note, I'm going to go ahead and start start the Devil's Playlist again. I'm going to pause the YouTube. We're going to take a little bit of a break. We're going to come back and we're going to look at some fun things you can do now with these colors. And we're going to add randomization to the colors so you can produce a random color. We're going to make a function to add to our tomb colors. And with that, we will then make programs using our library, including Nyan-Cat, which will just spew all kinds of crazy stuff to the thing. So we do have some time left here. We are going to go straight till 11 o'clock tonight. So we have another hour, and that'll be really where the really fun happens. So I'm going to take a quick break, so catch you in a bit. All right, welcome back, YouTube. Hope you had a rest like we did. We've only got an hour left to go, but this hour is going to be where the fun happens, right? So we've got this really great new thing, right? This thing that we can use to clear the screen, and we can use to print color, but it could use a little, fun. We need to make it so that it prints a random color. So first of all, let's use what we have already to make a program. Right now it's just a package, and the only way we've been able to actually see it work is by running our test. And that's all well and good, but it's not really useful, right? It's the way to go about doing this, but now we need to make a command. So if you'll harken back to last week, we talked about how to make a command. So to make a command, we follow the convention of making a CMD directory inside of our package, and it's inside of our module. And the key CMD package itself is just a holder for another package, and that's gonna have a main function in it. So we're gonna make another directory inside a command, and we'll call it, let's say, nyan. Okay, so let's let me just, this is a long-standing tradition with SKILSTAK. And so I'll give you a very short TLDR on why we do nyan. If you don't know Nyan-Cat, which is an ancient meme, you've been living under a rock. And a lot of these exercises came about from the students that I was working with. Some of them are very young. Asking them, what should we code? And they say, let's code Nyan-Cat. I'm like, okay. And then I would work in whatever it is that they wanted to code into sort of a lesson. And the Nyan-Cat is, I mean, the whole point of the Nyan-Cat is is that it just keeps saying yeah over and over again. It's just this huge repeat loop, right? We actually had somebody do a full ASCII text animation of Nyan-Cat. I wish I still had it. It's in my Python SKILSTAK library somewhere. It's absolutely brilliant. It's entirely ASCII art using nothing more than the stuff we've covered so far in the term stuff. So that's where this tradition comes from. So we're just going to call it nyan, right? And inside of inside of the command nyan, we need to make a file, right? And the file will be main.go, because why? Because this is a command. It's not a library package. And inside of there, when we open this up in VI, it automatically sets it up for us, right? And we can actually just change vimgo to nyan and save it, :w, and we actually have a command. So we can do go install .cmd nyan, and we'll get a nyan, right? A nyan or nyan, or whatever you want to call it. And you'll see that it prints nyan, but that's lame, right? That's not repetitive. It doesn't have any colors. So let's actually go add some stuff to it. So let's actually say I want it to print red, right? So red and then reset, right? Now you'll remember that that is not what we called it, right? It's actually term color. We know this from the test, right? So we did the test, and we this is how we do it. And if I had just opened up my package and looked at the test, an example test, I would know how to use my library, which is why we did example tests instead of the other testing. Term color reset, right? And that will actually work. And you'll notice it doesn't import it, so it's probably not going to work, right? So let's do a go install. And it's like, nope, don't know what term color is. So we have to go up here and add a bracket. and directly import it. So github.com/, I mean, we have to figure out what our path is. Now we can do this. Let's go up here and figure it out. We can do that. We can look at this. We can look at go.mod, which has it in there, and we can even actually cut and paste this using tmux space, and then go to the end, enter, and then come down here. We can paste that in, and so now we've got our term colors. That's interesting. Oh, we didn't do colors. I was wondering why it didn't populate automatically. Normally it will like put it in automatically. There we go. Okay. So that's good to know. And now we can do our install should work. So nyan, and now we get a red nyan. Well, obviously, what if we infinitely printed these? So this is the first introduction to looping and repeating that we've done in Go. So put your ears on if you haven't done this before. So we're going to do the infinite loops, infinite looping in Go. So, and we're going to talk about Control C, interrupt signal to stop things. Now we already covered this before, but we're going to repeat that again. So we want to infinitely loop. We want to print yan forever. So we do for and with nothing on it. And in Go, we would, I mean, in Bash, we would use the while true loop, right? Which we've done, and we learned that. But in Go, we just do a for loop with nothing in it. There is no while in Go. It's actually very unusual that the Go language has no while construct, but that just makes compilation even faster. So there's really no reason to have a while loop construct and a for loop construct because they're redundant. And Pike and the gang decided we're not doing it. And so they just made everything a for loop. And they specifically, when we use it like this, they call it a forever loop. So it's probably worth putting it in there. A forever looping. So, and that's a pretty common thing. I mean, the only way out of it is to interrupt. And interrupt is Control C. So this is well and good if you want to write an infinite loop. Sometimes you do, sometimes you don't. But we're going to do nyan, and then it will just print it forever. And it's printing it pretty damn fast, right? Because it's compiled. Let's see if we can get it to print it without a line return. How would we do that? So we would, instead of doing println, let's just do that. And now what do we get? Now we get something that fills our whole screen like crazy, right? But it's just begging to have random colors, right? So, I mean, look at how fast that is. It doesn't even wait. So let's actually make it kind of fun here. Let's give it a sleep interval, right? So this is the first time you've seen a sleep interval. So sleep. So we're going to do time.Sleep, which is something that is unique to Go, but not unique to Go, but it is different in JavaScript for sure. In this case, we just need to put a sleep here. So we do time.Sleep, and we can go look up sleep with Shift K. That'll show us the information about. It should anyway. Did I get it wrong? Is it daytime? I might have it wrong. It's not documented apparently. Okay. Anyway, so time.Sleep, and then we need to do the way sleep works is you have to have the number, and then you have to have the amount of time. So you do time.second or time.millisecond or time. Whatever, right? There's second, millisecond, and whatever. And you can go look up sleep and it'll show you all that stuff. Okay, so there we go. Constant second is the time duration of whatever. And it's important that you really deep dive into the time package of Go. We'll be, chinking away at it here and there. It's really, really significant. It's different than any other language I've ever seen. It uses a standard time point in time as its way of doing formatting, which is completely unlike anything I've ever used. And it might be a little problematic for those of you coming from other languages, but in this type, instead of sleep one and assuming it's milliseconds like Python or something else, or Bash, by the way, defaults to seconds. So if you want fractions of a second, you need to use 0. Whatever. But in this, you have to actually tell it what the interval is. So if I want to do 1 millisecond, it'd be a lot less, right? So now when I run it, I get I should get like 1 every second, right? And that's kind of lame. So let's make it a little bit faster than that. So let's say about every 100 milliseconds. Second. Yeah, 100 milliseconds. Let's do that. Go install Nyad, and then we'll run it. And there we go. That's kind of cool, huh? I mean, it's not as fun as it would be. But it would be so much cooler if we had, actual colors, right? So it's time for us to introduce randomization in Go and in Bash. Now, we did this in Bash already, but I want to revisit it because randomization is the secret to happiness when it comes to writing crazy fun gaming code, because you can't pretty much have any game without randomization. So we're going to do that. So first we're going to add randomization to Bash. So our term colors here, we have all these things here, right? But let's add a random color. So let's add a function. So we're going to do Bash first, and then we're going to do Go. So the first thing we're going to do is we're going to make a random function. So we're going to say, we'll say, how about rand color? All right. And we're going to use the syntax, which we've covered in Bash already. And we're going to use the Bash special random environment variable. This is very unique to Bash. You can use it in POSIX too, I think, POSIX shell. And so we're going to say, I want a random color. So what is the maximum number of colors we have, right? Well, it's supposed to be 8. We didn't finish our program here, but if it were 8, then we want to put that in there. And I mean, I suppose I should probably do them all. So we have black, red, what is it, green? I mean, if we're going to add them like this, we really need to do this, right? So black, green, red, yellow, right? Help me out if I'm wrong here. And then blue, right? Blue, 4, magenta, 5, cyan, I think is 6. Did I get that right? I don't know if I got that right. Term colors. Red, green, yellow, blue, magenta, cyan, white. Okay. Red, green. We're not going to do... Wait. Red, green, yellow, blue, magenta, cyan, white. Red, green, yellow, blue, cyan, magenta, cyan, white. And white is that right? We're gonna find out. So it's white. Yeah. Okay. And then reset and clear. We have them all. Okay. So we can actually cyan before magenta. Is it? I don't think so. That's after. According to this, anyway. Maybe I got that wrong. Did I have it wrong? If I have it wrong, let me know. I need to change it like in both places. Where do I have that covered? I don't know if I have it right. Let me check. Red, green, yellow, blue, magenta, cyan, white. Yeah, okay, good. Anyway, so you could also have the other ones. Thank you, recursion tree. So, so there we go. We got our stuff, yeah. And we got our bash. So there's our bash. So let's do a random color, right? Now this is kind of weird because we're not going to be using our variables. All right, we're going to return a value. We're going to return a value, and we're going to print that value. Now, my style of using functions is to call them and capture their output, which is slower than Go, but it's easier to do. It's like rancolor is actually a command that you've made somewhere. So then what would we do? We would do printf, right? And we would say, I want to print \e because we know it's going to be escaped. And then now this is where it gets interesting, right? So we know that's going to be replaced with something. And we're going to put a color there. Well, what is the color going to be? It's going to be a random, between 0 and 8. And the way to do that is to use the remainder operator, sometimes called the modulo operator, and we put an 8 there. So that returns a number between 1 and 8. And it uses remainder math to do that. And the random number, by the way, is some number between 0 and I think 32, 65. It's like some infinite number, right? So it's a high number. But you don't care, because all you really do is you want to take that a completely random number and reduce its interval between 0 and 8. And that will give us a random color. So now this is a little bit harder to test, but now you can do this. You can say, you can actually do a call, random color, and now we have like some random number, right? So we could say random, and if we run this code, we get a random color. Actually, it's the same every time, so it's not working. We need to get it's not working for some reason. We need to figure this out. I might have to do the calculate. Oh, I know why. Because I think this is being here. Just give me a second here. Oh, wait. We need to use, no. Oh, right. We're missing a 3. I don't know. Let's try it. Let's try that one first. Yeah, you're right. No, that wasn't it. There's something else. It's not fully evaluating properly. So I think I might have to use... I think I actually... Oh, God. Did I really just do that? I feel stupid. There we go. I didn't do the math. I did the other parameter expansion. So as you see, it's different every time, right? So while true, do term colors, sleep 1 done. And now you'll see the number is a different color every time. And I may have the numbers wrong. I think it's right though. The number of the module is always the total number of possibilities. And there's some bounds checking and stuff like that. I think it's actually 0 to 7, with 8 being the absolute maximum. So, I think we should probably turn it up and make sure we get the high number value. This is a little bit hard to test because the high number value, which is white, if we don't ever get a white, then we know our program's broken, right? But that's really hard to test. So let's do 0.1 and see if we don't get any whites. And so far we haven't gotten any whites, I don't think. Have we gotten any whites? I don't think we have. Have we gotten any? I guess let's add a thing in here. Let's add a test. Term colors. So anyway, we'll say I don't think it's ever actually hit 8. It should have though. I think 8 is the maximum. So we have 1, 2, 3, 4, 5, 6, 7, 8. What does white even look like, by the way? Let's do them all. And then we'll rank green, red, black, red, green, yellow, blue, magenta, cyan, white. All right, so red, we'll change that to green, yellow, blue, cyan, magenta, white. And red will change to green, yellow, blue, cyan, magenta, white. And the rest we don't care about, right? Then we have the rando color. So term colors. And there we go. And that's, you can, okay, so we did get white. We were getting white. It's kind of this like muted white. I'm pretty sure we had that. So let's actually try it again. Look at that, right? And you know, we can actually write nyan in here relatively easily. Watch. So nyan, and bash is so nice, right? So we can write nyan really easily. We can say user benny v bash, and we could say while true, do done, and I mean up here we can just do bang bang. Actually no, let's just do an R. We're gonna source this thing. Yeah, do you guys know about sourcing in bash? So this doesn't work unless it's run from some other place. I mean, it would be better to include it here, but we can actually do this. We can do source term colors, and as long as it's run in the same directory, that'll work, right? And then we could say printf nyan, and we don't even need a reset because it's going to do a new color every time. And then we can say rand color, and we should be done. Oopsie. I think we have to do that's slash term colors. Yeah, there we go. So there's our nyan cat, right, in bash. We're gonna do that same thing in let's put a sleep 0.01. How about that? So then we have this, right? And let's put a clear in there. So before we do it, let's actually put a clear. Let's say printf clear, right? And that should cover us. So now you have nyan cat. Yay! So that's the bash version. No. That's kind of fun. Now, I mean, you can obviously change the sleep interval. You can pass the sleep interval as an argument, and that might be a challenge for you. How would you pass that argument? And if there is an argument, use that argument instead. You know, you should be able to do that pretty easily. So let's do 0.001. See what happens with that. So now we have a pretty intense thing, right? Now you can turn off the cursor if you want. So you can't even see the cursor if you want to make it even better. And I'm going to leave that to you to do. Those are all ANSI escapes. There's like hundreds of them that you can go read about. And this is, hopefully this has just been kind of opening, you know, Pandora's box of like terminal possibilities to you about what you can do on the terminal. And we didn't even have to do any resets there because we have our prompt now. You should probably do a printf reset before, you know, the thing finishes. And you should probably also trap Control C. You could use Control R. Yeah, if you wanted to use a Control N there, then you would get this, right? And you could actually use a clear. This is kind of fun. You could actually use a clear every time. You can do printf clear, and now it looks like it's changing in place. So see that horrible, like that thing there, right? So that is, for that kind of thing, you might want to turn off the cursor, right? And that's stty minus echo. And if you do that, then you get, well, I guess I got it wrong. I forget how do you turn off the cursor? There's an ANSI escape for disabling the cursor. Yeah, it's set term, but there's actually there's an ANSI escape to do it as well, and it's faster, obviously, right? So let's see if we can find it. So cursor off. Oops. I know there's a way to do it. I just don't remember. So cursor off in terminal ANSI escape. So hydro mode cursor. Okay, so let's go see if we can find it. We just need to find the value. 25H. Oh, 25L. 25L. Okay, so there we go. So we can do printf clear and printf 25L /e. Actually, we could just do this. And we could probably make that, put that in our thing. 25L. I don't know. Let's see. Nope. That's not it. I know we can do it. I just don't remember. So, 25L. Wait, I forgot the bracket, right? Silly me. All right, so nope, not quite there. I have it coded someplace else if we have to go look it up. No, we're not using that. We're not calling a function. I don't want to call a function. It's overkill. Too much extra work. We don't need to. Yeah. According to curry cursor position is supposed to get character or terminal using ANSI. Disable hiding the cursor. I actually have. I forgot I had this. I have a function that does this. I totally forgot. There. Oh, I did turn off cursor off. Yeah. Well, I could have swore there was an escape for this. Maybe not. Let's see if there is. I mean, it's a good chance to check it out. It appears I was doing the same thing that you mentioned, so I could have swore there's a command for this. So I need the cursor putting in a new location. Wait. Putting in a new location. I know there's a way to do it. I just don't know it offhand. I'm kind of motivated to figure it out though. Yeah, I don't see it in anything. If you find something besides the function call, we could. I mean, it's only one call at the beginning of the program, so it's not that intense. So yeah. At the end of flying, your cursor for show cursor been a stage. Okay, so yeah. Did you figure it out? Is it a question mark? Does it actually have a question mark? Are you saying it actually had a question mark in it? Really? That's cool. Thank you for figuring that out. So it wasn't E, right? It was X1B. Oh, I didn't put a question mark here. Oh man, this is phenomenal. Oh, you win the prize, my dude, my friend. Thank you so much for that. So, PS caught it. Good dodge. Good job. And now we don't have to do the stupid call out to set term, right? Look at how beautiful that is. Oh my God, that's so beautiful. All right, now we should probably teach you. We should probably teach you about the trap command right now because I need to restore my prompt. I did Control C and now I'm screwed, right? I can't see my cursor anymore. So it's probably time to teach you about bash trap, and then we'll teach you all of the same things in Go before we end tonight. What time is it? So we have a half an hour. We got plenty of time. So the reason that we are left with a broken cursor is because we did not properly trap the command. Now, I'm going to introduce you to something in bash that you've never done before. And it's called bash trap command. Okay. Now, what the trap command does, so when you do Control C, it sends an interrupt to the program, which is why you should not get into the habit of using Control C for anything else but sending an interrupt. That includes a misguided replacement for escape when using VI. I'm winking at you, Prime Agent. So we have this basic thing, right? And then we need to set up a trap. And the trap is going to be, and I have to go look it up every time, man trap. Wait, sorry, this is a help thing because it's in bash. So we're going to go read about trap in bash. And I promise we're going to do the same thing in Go. So trap signals and other events. Defines the activates the handlers to be run when the shell receives a signal. A handler is a function that runs when an event happens. So it handles that event. That's what they're about. And it's JavaScript people know about this like very much. It's a trap. Now, arg is a command to be read, executed when the shell receives a signal spec. And I actually have a number of examples of this already. So I'm going to go into my .scripts. And I'm going to git grep all my examples of trap so you can see them. So here we go. So we have a lot of things here. See this cursor on, cursor off stuff. Well, that's the old school way of doing it. As of tonight, because of POSCOT, we now know we can do that without calling setTerm. We can actually do that same thing, but that's what we're looking for. And marquee, by the way, is, you know, kind of a blinking thing, right? So in fact, I don't remember marquee something. What does it actually even do? I don't remember. Oh, my Pomo command's dead. Oh, right. I forgot about that. Marquee is called all the time to, marquee is how I do my, it's broken right now, but that's how I do my term, my tmux. So when I do Pomo, it's actually part of the marquee. We talked about that when we did our bash RC. I'm not going to go back. I was just remembering it. Anyway, so let's look at our trap command. So this is the trap command that we want, but we want to modify this trap command. Now, sigterm init. So we're going to copy this. And I'm going to have to kind of remind myself how to use it because I don't remember, frankly. So I don't want to read all the man page. I just want to use my example. So we'll do that. And I'm going to paste this here. Okay, so we have trap. So what trap says is whenever the following signals, sigterm and sigint, so either of those, sigterm would be sent from a kill, and sigint is sent from a control C or kill. And so those are two things we generally want to trap, right? Whenever those two things are sent, we want to clear the screen, right? And in this case, we can echo capital clear because we already have that. And more importantly, though, we want to echo. We don't even really need to echo. We should probably printf. So let's printf, actually. Let's printf. It looks like I exit and then trap. And you have to call trap again, which is, this is annoying about trap, right? So what trap does is it says, okay, as soon as I execute, anytime these two signals happen, run this command in the quotes. And if you don't empty out the trap, you'll get this infinite trap loop. And so that's what this is about. Okay. This is zeroing out the trap. That's why I had to look it up because it's really weird. So we have the clear and we have the, we want to reinstate, I mean, we could have, so let's actually put this one in our term colors, right? So let's put it in our term colors. We have clear. So let's actually also have, actually that's probably something we want to, even if it's not interactive. So let's say we want to have cursor, and cursor equals cursor. Let's say cur on, let's say cur off, right? Cur off and cur on. And cur on, I think is 20. What was the other one? We looked it up. I just don't remember. It was is it H? Oh, it's 25H instead of L. I don't remember. So it's 25. It's 25H. Is that right? L to H. Okay. So now we have a cursor on, and we can have fun with this, right? So now we can actually call it from our other program. So we can say printf clear, and we're going to say cur on, right? And we don't need to do anything else there. Yep. Thank you very much. And okay, so So there we go. We got our trap. And why did we do that? Because watch, if I do neon cat now, I have a problem. What did I do wrong? Oh, wait. We need to, I mean, we can do this if we want. I guess it's probably wise. And that's because we have variables inside of there. So there it's didn't work. Oh, right, because we didn't turn it off. So we can do printf clear and cur off, and then we're going to trap it. We can do it in a reverse order, it doesn't matter. And now we have it. Now when I can do Control C, I get my cursor back. See that? Because I trapped it. Now if I comment out that trap line, I don't. And then I Control C and I don't have a cursor, right? And I know how to do that. I can do set term whatever, or I can execute like that. I can echo cur on, which we don't have because, I could actually source term colors, and then I could do echo cur on, and that'll turn my cursor on. It should anyway. Source term colors. Why didn't it do it? Interesting. Oh, did I do echo -e? Oh, duh. Printf cur on. Printf. No, still nothing. Did I not? Here. I guess not. -e. Huh. I must not have sourced it. Is my thing not sourcing? You know why? Because it's not a terminal. Yeah, it's because of this test. This test is telling it not to do anything. So that is why. But these should. Oh, I didn't export them. Yeah, let's do that. I didn't export them. Yes. We should export them. Okay, let's try it again. I mean, it's bash, right? We're supposed to be doing Go. Yeah, but I think this is going to work now. Yeah, there we go. All right, so anyway, that's what we wanted. And you can turn down the speed, and let's put the trap back on. So many people don't put traps in their scripts. It's really sad. And then they screw people up when they Control C it, You can put other things in there. You can actually put, you can put something like this. You can put something like interrupt detected or something. You know what I mean? You can put interrupt detected. And then put like a bash section in there. You can get, kind of fancy with it, right? It's like interrupt detected, and then it does the thing. And, and you can trap that command. It's kind of cool, huh? Yeah, you can run a function in the trap for sure. Yep. Yeah, you can actually replace all of this with a function name, and then you can put that as your handler, which might be cleaner depending on how long it is. Now this, I mentioned this already, but this to manage Go errors. No, the Go errors are fine. So this is to take out the trap. If you don't do that, then the trap that you have stays. So this is just good practice. What it does is it clears the trap that was previously there, so that a new trap is there, so there's no trap. And that's just standard. You should do that in general. As far as I know. I mean, I remember reading about that. That's all I can say about that. Yeah, you can have it do anything. You can have it be a finalizer, which is a word from the Java land, but so it clears stuff up from you. And that is not as something that I taught in Bash when we did Bash initially, because it wasn't really needed at the time. But it's super important that you know how to trap interrupts, and you can do it in Python. Python has an entire way to trap interrupts. you trap those exceptions, right? If you do a try except block and you accept on keyboard interrupt, and you can actually trap those as well in Python. JavaScript, same thing. Node, anyway. Go is the same. So those are all things you can do. I feel like in Go, trapping an interrupt is quite a bit harder, and I don't remember. You have to start using concurrency at that point. So we might not cover that tonight, that part of it, because it's pretty involved. How much time we got? We only have 15 minutes, 10 minutes. So let's just get this program to work in Go. Okay. So how would we write the same program in Go? That'll be our goal for tonight. And after that, we'll work on the trap, but I have a feeling the trap's going to have to wait till tomorrow, because we're going to have to create some concurrency and do keyboard interrupts, which has to introduce Go routines, and we don't want to get in there yet. We're still a beginner. So anyway, we have this this thing here, right? And we can actually add to our termcolors library the new ones that we have. So we can add cur on and an off, and we can do question mark. What was it? 25, 21L, and H. Did I get that right? 25, sorry. All right, so it's 25. All right, so we have a 5 here and a 5 here. On and off. And again, these are supported everywhere. So, this is kind of, oh, right. Cur on, off. Now that's kind of hard to test, as I said, right? So back to the regular thing. I mean, you can test it. This is example back. Let's just call it example. I mean, I don't know. This is kind of a tough one, right? We're also not doing random color. So we need to do random color, and we need to do the cursor on and off thing, which I wasn't really planning on doing tonight, but whatever. Let's do the random color first. So we need to implement that. So let's actually make a function. Now, this is a tough one, because this function is not going to have anything to evaluate. The only reason we're writing this example is the term colors.rand is to give an example. So we're not going to put output here, because the output is going to be different every time. So, we're going to compile it and make sure it actually works. For testing, however, just for initial testing, we can just put something random here so we can see what it actually outputs, right? So we can do fmt.println, and we're going to call c.rand, right? And that should print a random color. Now, if I do go test on that, it's going to fail because there's no such thing. So now it's time to add it. So we do termcolors.go, and we need a function. So func rand, and it's going to return what? It's going to return a string. Okay, so then we have, and let's go ahead and document it. Rand returns a random color ANSI escape between black and white. 37. Okay, so, and then we do that. So return blah, like the color. So we can actually do, so we actually have to get that. This is quite a bit more difficult than Go, because we have to get a random number, right? How do you get a random number in Go? You can't just use the built-in, right? You have to actually go get it. And let's do it. So how do I generate a random number in Go? And without getting into a really deep rabbit hole about true randomization and pseudo-random. Pseudo-random is predictable and not suitable for cryptography, but also a lot easier and kind of built in. So here we go. Generates a random integer. Now, there's a bunch of other rand stuff that we can look up. So let's do go doc rand. We know it's the rand package. It just so happens that I know that there's a thing called shuffle, which will give you a random, between a bunch of stuff. And I mean, there's a bunch of ways that we can do this. We're going to have to, we're gonna have to create a number and paste it together into a string and then output that string, because the string is going to be the thing that's going to get escaped. But there's lots of ways to do this. We could do, we could do this one. We could do the shuffle, which picks from a number of one of a number of different functions that are already there, and that will actually shuffle a given slice if you give it a slice. So I think in this case we want just a rand int, right? But we need to tell it, well, what is the lower number and what is the high number? And so let's look that up. Rand int. Int returns a non-positive pseudo-random integer from the default source. And I think you actually have to do the seed, if I remember right, in order to get this. And this gets into craziness with randomization, which I'd rather not break into right now, because the whole system randomization is based on dev random, which is generated from random entropy from the system, and Go goes against it. When we do this particular project in C, it's like really crazy, because we literally have to like read from a file handle, which is actually a device, the random device, the random device, and then get the random bits off of there, and then convert those into a number, and then take that number and convert that into our color. So it can be pretty hairy. So seed uses a provided seed value to initialize the default source to a deterministic state. And the thing about a seed is that when you do a seed, this is actually the reason Minecraft exists. Minecraft, every single world in Minecraft is based on a seed, seeding and randomization. So when you're dealing with pseudo-random numbers, if you provide the same seed, you always get the same set of random numbers. I don't know. Did they? Did they change random in Go 1.19? I mean, there was talk of it for the whole crypto thing and the whole fuzzing and everything. Go 1.19. As a part of the change, Go from now reformat stocks. Rand. Read no longer buffers random data obtained from the operating system between calls. Applications that perform small reads a higher frequency might choose to wrap reader and buff IO reader for performance reasons, taking care to use IO read full to ensure no partial reads occur. Huh. The prime implementation was changed to use only rejection sampling, which removes a bias when generating small primes in non-cryptographic. Interesting. Different outputs were given random source stream compared to the previous implementation. You can't break tests. Wow. Did not know that. Thank you for mentioning that. I don't think the average person is going to care. So let's actually do another search. Golang random number. And in Python, this is easy. In JavaScript, it's easy. In Bash, it's easy. In Go, it's not. You have to go look it up. But once you look it up, you don't have to do it again, right? So mathrand. Mathrand is not cryptorand, right? The random package contains multiple functions with different types of random functions. Below, make sure you import mathrand. Mathrand is pseudorandom, right? Cryptorand is like, it takes a lot longer, and it's safe for cryptography and that kind of thing. You usually don't need that, and usually don't want to make your game performance suffer from that. So setting random seed. So the first thing you have to do is set a seed, and you're almost always going to type this. And and the standard seed is just whatever the current second is. So let's do that. Why is it doing that? Okay, so we're going to do that. And and this is always the hard part about Go, because I feel like this is a little bit deep, kind of early, but whatever. Okay, so where are we? Where's my code? Where did my code go? 3. All right, here we go. So now technically you should call the seed every time, right? So we're going to do that. You don't have to though, right? If you want the whole program to use the same randoms. But if you do that, every time random is called, it will generate a new random. So we're going to do that. And then what? And then we need to v equals rand generates a random number. And then you modulo the random. So we're going to say v equals rand.int. And then we're going to need to modulo the rand just like we did with bash. And we could say, let's see, rand int n. Range is min to max. Oh, I didn't know there was an int n. Well, that's good to know. So there's an int n. And max minus min. So the maximum minus the min. The minimum is 0. And the maximum is 7. So 7 minus 0 is 7. So we'll put 7 here. And then we can return that number. So we're going to have to turn it into a number. So we use printf. Printf is printf, but it just turns it into a string. So we'll put that in here. 30 to 37. That might be. Yeah, I mean, it's going to get converted to a string anyway. So yeah, I don't know. I mean, yeah, definitely. I mean, it's definitely doable. So we could say 0, 33. And then now let's use printf because we want to use the v thing, right? So we're going to use the v, and we're going to use the bracket, and v is we're going to put a 3 there, and then the v, and then an m. Okay. And then we're going to give it RV. Now, that will convert an integer. If you try to do with a plus, you're going to get problems because it's going to say you can't join a string and an integer. But if you use printf, it'll do that conversion for you. So let's test our rand function. So termcolors test. Let's run and go test. And you'll see we got blah. Well, we didn't print anything. So print L. Oh no, we did. All right, so let's do a print F, and let's make it a Q so we can see that it's a different value every time, right? So let's do that. So we see that we got 35 that time, 33 that time, 31 that time, 35, 33, and I frequently will do this kind of thing, and then just delete the output, and just make sure that it works. Now, that will still test whether it compiles or not. It just isn't going to give you the output value. And I don't even know if it's going to be runnable. I mean, if you want to, you could put a fake output that says, and do some stupid test that sees whether, that's the actual value. But you can't actually test that value is that because it's different every time. So this is one of the cases where testing kind of breaks down because you have randomization. It's very hard to test randomization. But I mean, we've got enough to know that it works, right? So now we can start to use our termcolors, our new rand function, and we can put that into our 9cat over here, and we can say instead of wanting termcolors red, I want termcolors rand, and it's a function call now. It's not a constant, right? So, and we can do our reset, and we probably don't need to do much more. So we get to go install /. Don't forget the dot. It's really easy to forget. And we'll call nyan and see what happens. So there we go. We got our colors. Now, that was quite a bit more difficult than bash because all of that randomization was not built in to Go. I mean, the basis of it was built into there, but not something so simple that there's always a random number generated no matter what every time you access this environment variable, which is what we have with bash, right? And that pretty much concludes what we were going to do tonight. And I think there's a lot of stuff there. If you wanted to make the C simpler, you put C here and change your termcolors to C, or whatever you want, and that, of course, that only applies to the file. So a little bit easier to write there. And we can try our thing again. And now we got our nyan cat, right? And if we wanted to make it faster, let's do 10 milliseconds. How about that? So, oh wow, that's pretty cool, huh? Let's do it. Let's do the maximum speed possible, shall we? Let's eliminate the sleep completely. Watch it break my computer. What? Damn, that's fast. That's much faster than it was on my systems before. In fact, I think that's the fastest I've ever seen it. That's like so fast that the terminal can't keep up, and it's like blurring the things. Remove the cursor. Yes, we do that. All right, let's do remove the cursor. So, all right, let's add that. So let's add it to term colors and cursor off. Yeah. All right. So unfortunately, the trap is a pain in the ass and Go, but let's look it up. Okay. So we'll do that. We'll say fmt.print and we can print c.cur off, and this is going to break us, right? Because we already know it's going to break us, right? Wait, what? Why didn't it work? Why didn't cursor off work? Did I get it wrong? Cursor off. Oh, this is off and the other one's on. I got them backwards. All right, so let's try. Yeah, there we go. Yeah, that's insane. And I still have a cursor now. Damn it. Set term -- cursor on. What is it? Set term. There we go. Okay. So if you ever lose your cursor, there you go. That's how you recover it. I don't know if I want to tell you how to do trapping, and it's okay, I guess we're gonna have to go trapping interrupts. It's so much harder than Python. It is, because I have to introduce you to like concurrency and a bunch of stuff, and we're gonna add it, but you Go routines. I know. I realize that now. We're gonna have to throw Go routines at you, and it's kind of early. I mean, we're only on like the 4th project, but Go routines are a way to handle concurrency. Something is happening at the same time as something else, and I'm gonna add it just cause. I mean, we're probably past time, but still. Trapping interrupts in Go. It would be unwise to not know how to do this. How to trap OS exit, interrupt handling in Go. I mean, it's a pretty standard thing you can search for. We need interrupts. Here you go. So there's millions of reasons. Sleep. We don't want to do any of that. This is lame. I mean, I know how to do it. I just want to go look it up again to make sure that I have it right. Clear pending. Dynamic way of interrupt handling. Here we go. So this is old. This code is really old. All right. So you see down here where it says go whatever. So this runs the thing in a concurrency, and then it executes the next line right away. Is this embedded Go? This is embedded Go. Embedded Go doesn't handle interrupts. What the hell? And going programs. Let's look at this one. Oh, this is Nathan Leclerc. Nathan Leclerc is pretty funny, actually. It's on STM32, yeah. So, yeah. There's just like so much here to unpack. I don't know if I want to do it right now. God, try to do this in Rust. So, make channel. You have to make a channel to listen for the signals, and another channel to clean up when you're done, and then notify, and then you do the function. This is where your actual code runs. And then you have a signal channel. You got to make sure the signal channel is there. And if the signal channel actually ever reads anything, it'll get interrupted. So I actually have this in a library. And yeah, this is in my Z Bonsai library. I think it is. Maybe, I think it might be in my terminal library. Yeah, so in case you're wondering, if you go to my awesome Go list, artibixrob/awesome-go, or is it go-awesome? I can't remember. Anyway, I've put some of this stuff that you're going to regularly use into functions. So, hey, does this look familiar? Blank, calc, cyan, magenta. I did it all. But shh, pretend like you don't know this, okay? Including things that'll give you the exact size of your terminal. So this is RDBX-rob/term if you want to use that instead of, writing your own. Now, I suggest you still write your own. So you can actually turn off interactivity. You can detect interactivity. This is the whole, turning off the attributes kind of thing, depending on whether you have an interactive terminal or not. It does it automatically, by the way. When you import it, it detects whether it's interactive or not and sets the variables properly. But you can override that if you want. And it has an entire escape sub thing that has all the constants in it. So if you want every constant, they're under the escape sub thing. And there they all are. So here's every single constant that was from the wiki page that we saw. And you have bright, you have bold, and this is taken directly from that. We have a hide cursor and show cursor, which I apparently had forgotten about. So because I cannot remember ever doing that. Anyway, I don't think there's anything in there. I think in our examples we might have an interrupt. I don't think we do those. So we have simply read. You can actually change the values. So if you're doing testing and you want to see the colors work, you can actually define their values in the term and do that. And you can strip non-printable characters if you're really sure that something's going to be, you don't want all those characters. I mean, I wrote this package library to handle exactly this kind of thing regularly, but to use, and I have included the less stuff, which, most people don't care about. And then I have term.REPL prompt, and this will actually, there's a read evaluate print loop, but there. Anyway, you can go look at it and learn from it and see if there's something in there that you want to change. Maybe send me a PR if you find something you don't like. Here's the example of hidden text, read hidden, all this stuff. I use this in production. Actually, this is in production in several places in an enterprise because it uses a bunch of standards. There's the trap. We have term trap panic. And I don't think we'd have, I don't think I have a trap in here though, however, for a control C interrupt during the middle of that. I think it's actually going to leave. I don't remember though. I don't remember. I might, I don't know. I'll have to go look. So I'm kind of slowing down here because this is nothing you care about. But if you want to learn some stuff, you can go look through it. This attribute on detect interactive. Set interactive emphasis from less win size update. So and it happens automatically. We haven't got there yet. I'm not going to teach you how to do Go routines right now. All right. The repo is rdbxrob/term, TERM. And all of those are listed in my awesome Go list. So I have linked to other people's stuff and to my own stuff in there. If you want to kind of get a handle on Go, you want to run ahead and see how some of this stuff works. The term library has a bunch of stuff in there. I really, really don't want to teach you this right now. Not just because I'm tired, but because this is going to really confuse you. Because we haven't done anything with concurrency yet. And we need to start that. Normally, I teach concurrency when we do the Wandering Monsters story game thing. And we have something happening at, in external intervals that don't depend on the flow of the game. So I would rather wait and introduce you to concurrency at that time than to do it right here. Right. I made a mistake by showing you the bash trap. The bash trap is pretty easy, right? And unfortunately it's not nearly that easy in Go. So we're not going to do that in Go right now. Just know this, just know that if you get stuck, you can go to the research on it. But remember set term, -- cursor on if you get stuck without a cursor. Okay. So if you get stuck without a cursor, remember that. The bash trap command for restoring cursor. We've never actually turned the cursor off in the Nyan project ever since I started it. I just happened to do it tonight because I thought of it, and then I didn't realize what kind of a can of worms it was going to pull in. Most of the time when we touch on this with beginners, we just leave the cursor there and we're good to go. We don't talk about that at all. But it was annoying enough to go down that rabbit hole. And that's going to be it for tonight. So, we got 9cat and then we cancel it, and then we're like, oh no, set term. I mean, you're going to need to load this anyway, so maybe it's good. Because I guarantee you'll find some bad code out there that does what 9cat's doing right now. It does not do it, right? And you'll need to turn your cursor back on. You're like, oh no, my cursor's off. And now you know how to do it. So consider that a win. And we'll address the other stuff when we get to it. So we did turn colors, we did 9cat. We have not done any RGB color sequences. And I don't know if we should actually do that. I'm seriously thinking about dropping this particular challenge. So this is kind of a bonus. I mean, y'all tell me right now. I'm gonna sign up for the night, but please tell me, do you want to have an RGB command that will take 3 RGB values between 0 and 255, combine them together, and print that specific color? Do you care about that? I don't think it is as important. I think that the RGB colors are nice if you're making a game where you want to control a color, but I think that sticking with the generic term colors, the 8 term colors, is far better because of the theming that we talked about. If you use RGB colors, they never change. They're always the same color. They're blue no matter what. They're not blue and then green if it's another theme, right? So I think it might be worth getting rid of RGB. In fact, I'm gonna just get rid of it because we got to move on. I'll just say this, okay? So there is a huge rabbit hole when it comes to terminal colors and terminal escape sequences, and there is a lot of stuff. In fact, one of the coolest projects that one of my students that I mentored made. In fact, I'll go show it to you. Is something called GitLab. It's on GitLab, and it's called term color or something. And it's a way to interactively choose colors with their values. And he wrote this as one of his major projects while he was doing his thing. So I'm trying to. It's a term picker, color picker. Color picker, and no. What was his name? I forget his name now. I forget his name. He made an entire package. It's really cool. Oh, here it is. CPIC. Yeah. All right. So let me tell you about Ethan. Yeah, Ethan CPIC. So Ethan is like crazy amazing. He's done crazy cool stuff. He hasn't probably edited this stuff very much. He took this idea and just totally ran with it. Hey Chris. He took this idea and he totally ran with it. He made an entire term down or C term package library that has selectable colors using T-cell. It's so amazing if you want to use it, and it's cool. I mean, I don't know if you can see it, but he's got it so that you can actually use your mouse and go or use your keys and go back and forth and pick all the different colors, and it gives you the RGB value. And this is all in the terminal. Entirely in the terminal. And when it ends, it actually spits out. So you can use it as a Vim filter, and it will actually spit out the values in that language for the thing that you just picked. It's so stinking cool. We worked on it for a while, but it's pretty amazing. And so if you want to play that, it's called cpic. I think it is actually on. I think you might actually have a command. Yeah, command cpic. In fact, let's try it. Let's do Ether Baker cpic. I think I might be able to. Did he move it to GitHub? He did. He moved to GitHub. Okay, so let's try. I miss Ethan actually a lot. He was an amazing kid. He's not a kid. He's an adult. He's off in college now. But go install. I haven't seen that one yet. Let's go see. At latest. Okay, so then we can use it. The mod file. One or more replace directives. It must not contain directive that would cause it to be interpreted differently if the. Yeah, I was afraid of this. He needs to upgrade. He needs to upgrade at 1.18. He hasn't done that. I probably could do. No, I don't think I can. I think I have to have go 1.13. Yeah, it's too old. It's too bad. Yeah, he doesn't know better, but because he hasn't probably worked on it. He's in college now. But go 1.18. It says go 1.18. You the go to way to install is to go. He's got replace directives in here, and that's a problem. Yeah, he needs to get rid of his replace directives. Yes, and he can't do that. And my files have module containing. I should probably fork it. I should probably fork it and fix that. Let me do that, and I'll give him a. I'm gonna fork it and give him a branch. I'll give him a PR on this. He doesn't know because he hasn't used it forever. So let's do that. Let's clone cpic really quick. That's my cpic, but not right. And I'm gonna go fix this thing here. Go mod. Yeah, he's got to replace directives. He's replacing cview with cpic cview. He altered cview, which is probably not a good idea. Yeah, that's probably a bad idea. Anyway, so I think I can actually go install this. So let's do that. It might yell at me, but I don't know. It's going to get all the stuff. GDA more. I'm actually a sponsor of GDA more's term T-cell. It's really good for doing terminal stuff. And what else? All right, so go install /command cpic. I'm using VI. I'm using Vim. Yeah, I use VI because of the memory stuff. So there it is. Now you can see that my terminal is broken, right? I told you about it not having the right colors. Because I have, look at that. See, mine is being limited to like less than millions of colors. This would look much better if it, but you can't even see it really actually at the moment. This is cool. I've never run this on Windows. But you can go here and you can pick it. And then when you pick one, you push enter and you can actually do cpic -bash -h. It'll tell you everything. Whoops. It should anyway. I think it might be -bash. Yeah, dark tint. Enter. It's much better on a term. I need to fix my tmux. Sorry about that. My tmux is not currently in a good state. It doesn't show the difference, and there's something missing from this that I'm having a problem with. Yeah, it was one of his first programs, so he's got some things. Oh, here we go. So he's using command tab. God, the command tab is old. So bash. Okay, so we're gonna say cpic bash. The reason for this is because when you actually do pick a color and you hit enter, I mean you can't see it because it's. I need to set the colors. You see what it did? Read only. It sets a constant that defines the custom color to be the name of the RGB color that you picked. It's really cool. And if you want to actually get into colors and stuff, you can go, have a look at HTTPS xrob cpic, which is actually Ethan cpic for RGB colors. We're not going to do more than that. Okay. Yeah, we're not going to go beyond that. And that's it. So here we go. We're about to wrap up for tonight for the beginner boost, and then I can take other questions and stuff. So if anybody has any questions, go ahead and do it. So that's really all we're going to do with terminal and Go. Everything else is going to be adding it as we need to. We're not going to deep dive. We will get to how to trap interrupts in Go when we do concurrency, which is not going to be for a while, but we will eventually get there, I promise. And that's really all I have to say, YouTube. So have a great night, the rest of your Friday, and we'll see you later.